PGDay here, Rotterdam, yeah, 20 to 5, Lowlands is live. PGDay here, Rotterdam, yeah, 20 to 5, Lowlands is live. PGDay here, PGDay here, PGDay here, PGDay. PGDay, 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 PGDay here, Rotterdam, yeah, 20 to 5, Lowlands is live.
Welcome to PGDay Lowlands, Rotterdam 2025.
PGDay here, Rotterdam, yeah, 20 to 5, Lowlands is live. PGDay here, Rotterdam, yeah, 20 to 5, Lowlands is live. PGDay here, PGDay here, PGDay here, PGDay. PGDay, 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 PGDay here, Rotterdam, yeah, 20 to 5, Lowlands is live.
Welcome to PGDay Lowlands, Rotterdam 2025.
PGDay here, Rotterdam, yeah, 20 to 5, Lowlands is live. PGDay here, Rotterdam, yeah, 20 to 5, Lowlands is live. PGDay here, PGDay here, PGDay here, PGDay.
Okay, hello everybody.
PGDay.
Almost everybody is already in the room, but we are going to start because we are a little bit late. The only reason that we started with a few minutes of delay is because everybody was amazed by the entrance and they forgot that they were coming to a Postgres event, and then they were stuck in the tunnel looking at the nice fishes that we have in this particularly beautiful zoo called Blijdorp, which actually for the people who don't speak Dutch translates to happy town, isn't it? Blijdorp, yeah, excellent. Okay, good. This is PGDay Lowlands, as you know. This is the second edition of PGDay Lowlands. We have grown a little bit, and now it's in Rotterdam. So we went from 100 attendees last year, and we have 115 this year. So we are growing. Thank you, thank you, thank you. Now, not only in Rotterdam, but as you know, and you saw it, we are in this zoo, particularly nice. And you're going to have a little bit of time also to explore the zoo before lunch. We're going to give you more information about that very, very soon. Now, because we are in a zoo, I wanted to quote some ideas that are coming from people that observe the behavior of animals, and they try to get some inspiration from them. For instance, this citation from the book, The Jungle Book, that says, the strength of the pack is the wolf, and the strength of the wolf is the pack. The pack is the group of the wolves that are all together. That means that the pack doesn't exist without the wolf, and the wolf doesn't get as strong when it's alone and it's with the whole pack. Yeah. So that's important. It talks about community, about how we are integrated in the Postgres community. Yeah. So try to remember that and try to get that as inspiration. Now, of course, our logo is an elephant. So when you start looking at elephants in general, you will observe that their behavior is really, really, really a social behavior. They are always with the family, and it's being also observed in refuges for places for rescuing elephants that are in the wild. That when they come to the place, all the other elephants receive them very, very easily and welcome them in a very familiar way, because this is their behavior. Now, of course, you may say, well, there are other animals that are super aggressive and everything. So what are you trying to say here? Well, I'm not trying to prove anything. I'm just trying to get inspiration from the animal behavior so that we can get our own choices, because that's the difference between human beings, which are also part of the animal kingdom, but we have taken a step further to go beyond the instinct. Is we have a choice. We have a choice to behave like we want to behave. And then citing Viktor Frankl, he explains that there are two ways of, multiple ways, but you have the mass of people, the mass of production, where actually everybody in that mass is like a stone, and you can replace one stone by another one because they're all completely equal, and the individual kind of disappear. Whereas in a community, and he used the word community, which is very nice for us, the Postgres community, the individual's uniqueness shines through in the community. So imagine somebody who just go and live alone. He might also develop himself as a good person, but through the community is going to be able to shine more because his development as a person will reach all the people as well. Now, what he also said is that the community becomes meaningful only through the existence of all the unique individuals within it. So think about it. The individual shines through the community, and the community becomes meaningful through the individuals, which kind of seems very similar to the wolf and the pack. So it's our choice to behave like this. And you are also, as individuals here, and I invite you to take this day, not just an extra work day that is fun because we are in a zoo, but also to see how you can contribute to the community and how the community contributes to you. So take this opportunity during the day. And it's a choice. It's not instinct. There is a little bit of instinct, but you can go beyond that and take your particular behavior. Now, because individuals are important, it's also very important to recognize the contribution of each of the individuals. And I'm going to be mentioning some of the people who were behind all the work that was done here for being in this nice show to organize the PGDay Lowlands. So this is the organizing committee, and I will ask an applause for Sarah, Flor, Dirk, Teresa, Nico, Stacy, and yours truly. Now, we don't have only the organizers, of course. We also have a program committee chaired by Teresa again. And these are volunteers that did a fantastic job picking up nice talk. So I would like to also thank Carol, Chris, Gerard, and Emma. Now, as individuals in this community, we also like to behave in a nice way with the rest of the community. And that's why there is a code of conduct, just to make it explicit for some people who, like you said, what does it mean to behave correctly? And then you can go and check that. If you don't feel comfortable for any particular reason, there is this people that are here, which is Flor and Jos. Jos, where are you? Okay, yeah. So Jos is here, so you can see. Thank you. And Flor is there. Flor is wearing a T-shirt from the organizing team. Jos is our external code conduct committee. So if you have a problem with somebody wearing this T-shirt from the organization, you can also go to Jos. Okay. Now we have another person for the code of conduct committee, which is Sarah. I'm going to refer to her a little bit later. So we also have the speakers. I'm not going to name them all of them because you're going to see them one by one. And so these are all the speakers that we are going to have today. So please give them an applause to them as well. And the debaters who are going to be on this stage fighting for their ideas. Right, good. We have still running a testing challenge. Until last night, it was possible to submit a test of PostgreSQL 18 release candidate 1 or beta 3 or whatever you were able to test before the release, because finding bugs 1 week after the official release is okay, but it's better to have them before the official release. So if you want to contribute with testing, you can still do it. We are going to have a wall of testers, so we are going to list you there. But if you did it before, you have a possibility of winning some prizes. We have Jimmy Angelakos, who donated not only 1, but 2 books now. We also have a nice pin made by Chris, an elephant made by Karen, and also we got lately a donation by Eileen about her book as well. So we have prizes for people who contribute to Postgres. So that's super nice. Now, once you organize a conference, you realize that it's not possible, really, it's not possible to do it without the sponsors. So I'm going to name our partner sponsorship, and I would like to get an applause for each of them separately. We have Cybertech, Kangaroo, Credative, Nibble IT, Optima Data, Adyen, Ivan, and EDB. Good. I had to practice a lot to don't confuse Adyen and Ivan because they sound very similar, but there's 2 different companies. Now we also have sponsors that are not here in the booth, but there are supporter sponsors. So please also give it a hand to PGX, Microsoft, Navicat, and AWS. Now, from the sponsors that are here, 5 of them are coming back to PGDay Lowlands, 3 of them are new. If you want to know who are who, you need to go and ask them. And when you ask them, you are going to have the chance also to fill in the sponsor passport. So you get a passport, then you get it there, boom, they give you a stamp with a very ridiculous stamp animal, boom. But it's a valid one, although it's ridiculous, a very valid one, because you can win prizes that we are going to raffle at the end of the day. Yeah, so fill it in, give it to us, and then you can win some particularly Dutch prizes, okay, because we are in the Netherlands. All right, so use the sponsor passport. If you haven't get this one and the registration desk, you can still get another one during the break. All right, so red lanyards, these people are not willing for you to take a picture of them and publish it outside. Blue lanyards are okay with any picture, yeah? So the people who have this blue lanyard, you take them picture and they can put it in social and say like, hey, look, I'm having a good time and PGDay Lowlands. So these are your pictures, but we also have some professional picture from Tom, which is there. So if you see Tom with his camera, he likes people smiling, and then or maybe making funny faces, imitating animals. If you feel your wolf inside of you, you can show your wolf face to Tom, and he's going to take a picture. Good. So we have a schedule. We have some changes in the schedule. If you cannot see it yet, you can go to the website. I'm not going to go through that one right now, but that's the schedule. Now, we also have debates, and we have the best person for organizing the debates and moderate them, which is Flor, who is going to be making sure that people with an idea will come here and defend the idea in a respectful way. Now, for the debates, we were talking about the human being that have this curiosity and this choice, but our minds are not designed to find truth. Our minds are designed to survive. We just evolved to survive. So the mind tricks us many, many times just to confirm things that we want to be true. Yeah? So this is called confirmation bias. There are other ways of tricking our mind. So critical thinking is not easy. But the first one that you probably want to avoid is confirmation bias. So I invite you to go with curiosity, meaning forget about your confirmation bias. Don't arrive to the debate saying like, I'm pretty sure that containers are the best solution. So show me the arguments to be convinced even more about it. No, come and listen, and maybe you might even change your mind during the debates. That's why we have the debates. Okay, so that's an invitation. Now we also have a live streaming. Where's the camera? Here. We have a live streaming, and then if people don't behave well during the chat at the live stream on YouTube, because we have a channel where there you can watch the recording of these talks for today, then Sarah Conway, which is the Code of Conduct Committee for the virtual stuff, is going to be there, making sure that people behave like in a community. All right, so during the day, you can give feedback to the speakers. It's super important. You can also, at the end of the day, give feedback to us and as organizers so that we know what we can improve for the next edition and what we can keep on doing. So don't forget the feedback. And while you're in the hall, you try to respect the Pac-Man rule. The Pac-Man rule is coming from people from other communities that have teach us how to be more open to other people. Look at these animals, elephants that are kind of sad because they're in a closed group. If they are much happier, like with color, you can see that they have like a Pac-Man, like an opening, because they can welcome another elephant that can join them. So when you're in a group, try to always keep a space for anybody to join. Otherwise, it's super difficult to try to get into a conversation. And once you receive the new elephant, you can still open again. And always try to keep this Pac-Man rule. All right? So after this, there is going to be some social possibilities to talk to other people and then share some nice thoughts and what you learn from the debates, for instance. And finally, let me just tell you that if you want to go social, you can go in these links and then put your pictures, put your comment, put your thoughts, and then be part of the community and think about how you can contribute and shine through the community during the day and after this day. So thank you very much. And we are going to start with the talks, and the first speaker is going to come here, and he's a very good friend of mine. Let me help him put his laptop. And we're going to start with the schedule. We are a little bit late because of the arrival of the people, but we will catch up, don't worry.
20 to 5, Lowland is live. PGDay here, Rotterdam, yeah. 20 to 5, Lowland is live. PGDay here, PGDay here, PGDay here, PGDay, 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 PGDay here.
All right, so we go with the first talk. You probably have heard about Jimmy before. He's a very good friend of mine. I'm super happy that the program committee selected him for giving this first talk here. And Jimmy is actually a very good musician. He has a very nice voice, and he also enjoys karaoke. So you might find him tonight if you join us for karaoke. So he's going to be talking about bringing Postgres to the next level. And please welcome Jimmy Angelakos.
Thank you. Can anyone hear me? Mute. Hello? Hello? Mic check. Hello? Hello? How about now? 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 Switch it off and on again. How about now? How about I start shouting? You can give me the testing. Yeah, great. Cool. Right. So thank you so much for coming to the very first session. It's not usual to get a crowd in the first session, so I appreciate that. Right. So I only have 20 minutes. So please leave your questions to the end of the session. How do we get Postgres to the next level? What is the motivation for this talk? The motivation is that if you haven't understood this by now, Postgres is kind of important. And Postgres is also accelerating, which I think is the reason why you showed up to the early morning session as well. Postgres, some people, I would, is probably becoming the next Linux in the sense that it is so important that everything is running on Linux. And I think we're reaching a point where anything that's using a relational database will soon be running on Postgres. Already, most of the major, let's say, businesses and corporations are switching or have already switched totally to Postgres. And this means something. I co-wrote this talk with Hedy Dombrovskaya, who is a database architect at DRW. She's also the founder of Prairie Postgres non-profit organization. She's the communications chair for the ACM in Chicago. She has recently been elected to the Linux Professional Institute Board of Directors. She's also the local Postgres user group organizer and is organizing a brand new conference called PGData in Chicago. She has also co-written a book which is fantastic about Postgres query optimization. Unfortunately, she wasn't able to come co-present this at PGDay Lowlands, but let me just go through a few details about myself. I'm a systems and database architect. I'm based in Edinburgh, across the sea. I have been using open source and trying to contribute to open source for the past 25 years. Postgres exclusively for the past 17 years, both in a personal and a professional use. I'm a member of the Postgres Europe Diversity Committee. I've written a book called Postgres Mistakes and How to Avoid Them, co-written another book called the Postgres 16 Administration Cookbook, and a Postgres extension called PG StatViz for the visualization and time series analysis of Postgres internal statistics. Now, some of this talk is based on ideas that were presented by the late, great Simon Riggs in his keynote in Prague at PGConf.eu 2023. His talk is linked in the slides, but you can find it on YouTube at the PGConf.eu channel. It was called The Next 20 Years, and he tried to predict things that would happen with Postgres and to Postgres in the next 20 years. We've selectively picked a few points from his presentation to discuss. We believe that the three pillars for the future of Postgres are, first of all, improving the code quality. Second, adding new features to Postgres. And third, advocacy and growing the community. And I will go into each one of those pillars in some detail. So the code quality, what do we mean by that? And why is it important? So code quality is critically important because we want reliability. And if you're an organization, whether it's an institution or a corporation or a private user that runs critical systems, and you want those systems to remain operational and reliable at the order of millions of operations a second, then you want Postgres to be reliable for that. And this is also why we want to take Postgres to the next level, and we don't want to be considered a database for startups, as Postgres was considered until recent years. So how do we get there? How do we improve code quality in the Postgres project? First of all, we have great tests, but we need to expand the test coverage. And also we need to think about benchmarking in a very serious way. Benchmarking for Postgres is different than any other database because we are not afraid of getting bad results, right? If we get bad results in our benchmarks, that's the best thing for us because we know there's a problem and we can fix it. So it's a positive thing. We're not this other corporate commercial database that sues you for publishing benchmarks, right? And to do that, we probably should establish a dedicated performance team. People who only worry about this day and night. They write the tests, they expose the problems, they suggest solutions, and then those solutions get applied to the core code. Another thing we can do is define what Postgres is. So let's say that standard Postgres is something that is compatible with Postgres. What is compatibility, right? So what are the tests that need to pass so that we can say that this thing is Postgres compatible? We have seen this term thrown around in recent years. with various degrees of compatibility touted as being Postgres compatible. In some cases, the databases that are marketed as Postgres compatible are not even relational databases. So that's completely ridiculous. We need to fix that. So in Postgres Europe, in Riga, later this year, we've set up during the Community Day a session a working session where we can discuss this, where we can come up with ideas and tests to establish a standard and say that this is Postgres. Anything that doesn't pass these tests is not Postgres. Simple. Right. So, again, how do we get to the point where we have better code quality? Another thing we can do is uncouple the development of Postgres subsystems. So right now, Postgres is a big monolithic chunk of code, which isn't terribly bad, but as the project grows, it is really difficult to swap in bits and swap out bits, which is why we're stuck with one table access method, basically, that everyone uses. Everything else is an extension, right? It would be nice if we could uncouple the development of subsystems, and if we could also version subsystems and say that, oh, you know, I'm running the latest Postgres, but I'm also running AIO version 2, which is more advanced than AIO version 1 for asynchronous I/O, right? So it would be good. And you could also, if you were adventurous enough, be able to run the stable versions of a subsystem, but also try out the experimental versions of a subsystem in the same Postgres installation. So to do that, we need ways to build Postgres in a modular way, which isn't possible right now. And if you have modules, of course, you need a dependency system, because you don't want one experimental version of a subsystem causing incompatibilities with the rest. Now, let's move to adding new features, which is a point of contention, because the developers of Postgres think that some features are needed and are working very hard to roll them out. But is that in line with what the users of Postgres want? So, survey says, we had a survey, and very informal one on the internet, and we asked people what they would like to see in Postgres most. 20%, that was the top percentage of responses, said they would like to see vacuum gone forever. Which isn't what the developers are working on. It's not even close to being what the developers are working on. The second thing was online major version upgrades. It's a major pain point right now. If you're running Postgres in production and you want to upgrade to the next version, you have to find a way to minimize your downtime, because downtime is inevitable. In the third position, we have a shared request, 8%, for easy database forking for testing, because right now you have to do this whole dump and restore procedure in order to be able to fork your database to give to your developers for testing. And also bitemporal tables, which is also known as time travel. Tables that store every change that's ever happened to them, and you can query a table at some point in the past without having to keep separate history or auditing tables, as many of us do. So what do we observe? We observe that all of the finalists are unexpected. They're not things people are talking about visibly on their blogs or on the internet, or more importantly, on the development mailing lists. So what we would presume before holding the survey that the favorites would be, we were discussing optimizer hints, we were discussing multi-threading, we were discussing built-in high availability features like building PG bouncer inside of Postgres. None of them made the list. They were very low in terms of user priorities. Other features that we can talk about that would be nice to have in Postgres would be an in-memory hash table, something like a built-in Redis thing, so that we could have fast, minimal access to huge data. And also we could use such a thing for global query caching, which is a feature that people are asking of Postgres and we don't have it. And you could also cheat and serve slightly stale data with result caching if it's not critical. Sharding is another feature, but what does it mean? Because people have multiple concepts of what sharding means. So it's not just about to be able to connect to nodes holding different data sets, because that can also be implemented in a workaround way or with extensions that people have built with foreign data wrappers and so on. So I think the big question to be asked is, how do I perform a point-in-time recovery and restore the entire cluster of sharded nodes to that specific point in time, right? This is something people haven't thought about, but it's really important in a, let's say, enterprise scenario. Also, we are getting requests to improve Postgres' scalability. Multi-threading is one of those things that could improve scalability for large enterprise environments. So what do we get out of this? We need to actively listen to the community. We need to start listening to the user base, because the features they want, if they don't get them, they will find a database that gives them those features and use that. Now, we mentioned the community. What is the community? So the Postgres community is a diverse global network. It is not just a small group of core developers and their friends anymore. Right? So we're talking here about individuals who are using Postgres, who are contributing to Postgres, who are coding for Postgres, right? And who are advocating for its use. And these are the people who build and promote Postgres. They are also companies. Companies are part of the community. Do I see surprised looks? No, because generally speaking, in the open source world, we tend not to think of companies as members of our community, but they are, because they employ the contributors that actually build Postgres. In some cases, they build their solutions on Postgres, and in that way, they invest in the ecosystem of Postgres. And then finally, we have the end users. The end users are private users, public users, corporate entities. They rely on Postgres to get stuff done. So how do we reach out to the community and how do we perform advocacy? We really need to think about this because we haven't been the greatest project at it. So what we should do is understand the human trends and how they impact the adoption of Postgres. So we're talking about what developers prefer, we're talking about what users expect, and we're talking about workforce and skills. What does that mean? How do people build up skills around Postgres, right? What is their Postgres knowledge level? Can they find jobs relevant to Postgres, and so on? So the Postgres project does need to change, and it needs to grow to be able to cope with the growing user base that we're seeing. We need to welcome as many people as possible and as many organizations, whatever organizations means, into the community. And by organizations, I mean all these users that I mentioned previously. We do need to learn from other open source projects, and we need to adapt their successful strategies. We need to see how they broke through to the developer community, how they broke through to the corporate world, and try to emulate them. For that, and for building up skills, we definitely need official training materials. We have a couple of pages of documentation that are great. They're very dry and very technical. We have a couple of tutorials that haven't been updated in 20 years probably. We require for this a dedicated documentation and training team in the project because it's a full-time job. We can't rely on the developers who are working so hard to bring you all of this to also produce training materials because it's another full-time job they need to have. Again, on the topic of advocacy, we need to demonstrate the power of Postgres. We need to attract developers, and we need to attract non-code contributors as well to the project. The people who are demonstrating the power of Postgres and talking about it and promoting it. And back to the developers, when we're talking about Postgres developers, or people who would like to develop for Postgres, we are kind of unfriendly to someone who wants to get started. I've seen countless questions on mailing lists and threads and Slack and whatever saying, I want to start coding for Postgres. How can I do that? And the question is inevitably, oh, go find something or review someone else's patch. That's not helpful to someone who doesn't know anything about how the project works. The development workflow is a big problem. It is stuck in the past. Developers who come out of school now are not familiar with this development workflow, that there's one mailing list. We discuss everything on the same mailing list. This mailing list, for me, is a huge problem and is driving people away. I used to read it. I don't anymore because it's getting 3,000 emails a month. That is an insane amount of traffic, right? So it needs to be broken up. We need to rethink this because it's not easy for people to penetrate our world. So the 2025 Stack Overflow survey recently came out. For professional developers, the most popular technologies, as you will see, are Postgres, and far behind is everyone else. But for those learning to code, Postgres isn't at the top for some reason. It's in third position, and it's like almost 10 points behind. Why is that? So this tells us that application developers, not Postgres developers, right? People who are using Postgres to build applications do not have a good entry point to our project. And this may lead to a potentially negative experience. One thing we could do is have a professional advocacy foundation, which of course would be accountable to the project's leadership, and it would do targeted marketing, strategic communications, and so on, everything that you need to break through. It would promote the brand of Postgres, and it would enhance the perception of Postgres among enterprise, developers, decision makers, researchers, and educational institutions. Postgres is not there in academia. It should be everywhere, and universities are not using it. So it would also ensure the consistent representation of Postgres at big tech events, and not just our lovely small Postgres-specific ones. So, in conclusion, Postgres is gaining popularity, and it's attracting new users from everywhere, but we need to support its position as the market leader that it recently became, right? We need to standardize, we need to focus on our code quality, and we need to focus on our tests. We need to empower the development of new features instead of telling people, go on this list with 3,000 emails a month and try to get your code in, which is impossible. If you've tried to send the smallest patch to the PG Hackers mailing list, and you're not an existing Postgres committer, it's nearly impossible. The future of Postgres depends on our community. We should invest in it. We should actively engage with the community, and we should expand it through advocacy, as we said, and make our changes look inward and make changes in the project to accommodate that. So, some shameless plugs for the last few seconds. PG Data is happening in Chicago next year. The CFP opens next month. It's going to be a fantastic event. And as a thank you for braving, someone shouting at you for the first session, I can give you a discount code for my book and anything else on the Manning website. Any questions? Yes. Thank you.
Question? Yeah.
So apparently, according to a survey of a user base, I don't know what it was founded on, 20% of the people think that vacuum is a problem. In my experience, what I've seen so far is when vacuum is a problem, it's usually because of bad tuning or no tuning at all, or not understanding how vacuum works.
I agree with you 100%.
Okay.
Is it a problem that people run into? Yes, it is. Because they don't want to worry about this sort of thing, right? If they're very advanced DBAs and they've spent a lot of years tuning and worrying about how Postgres works, yes, they are aware of this and they take care of auto vacuum, they take care of all the settings. But it doesn't work out of the box for most of the people.
So what I'm actually really surprised of is that not the top of the list is that out of the box, Postgres is tuned for a Raspberry Pi.
Sorry?
That Postgres out of the box is tuned for a Raspberry Pi and not for a server that it actually runs on.
Yes. Now that's a different story. The defaults of Postgres are very conservative and they're meant to help you run it anywhere, right? If you try to install like a huge commercial database that we won't mention on your laptop, it will require more memory than you have on your laptop by default. So you're not even able to install it. So that's why the defaults are very conservative. But yes, you need to be aware, and this is in my book, by the way. You need to be aware that the defaults are ultra conservative and are not suitable for use in production. Yes.
Okay, so we have time for only one question, and then we...
I couldn't hear you, sorry. Okay, so out of the box, Postgres runs much faster than some other database. Yeah, okay. It could be true, but every workload is different, right? You need to think about this. Every workload is different. So what's working fast for you, the same settings will not work for someone else.
Jimmy is going to be the whole day here, so you can ask him questions then during the break. And we also would like to give him a handmade key ring as a special present for our speaker. So please give applause for Jimmy once again.
Thank you so much.
Okay, so Gulchin, where is Gulchin? Ah, here is my friend Gulchin.
PGDay,
Yes.
PGDay here, Rotterdam, yeah, 20 to 5, Lowland is live.
Welcome to PGDay Lowlands, Rotterdam 2025.
Lowland is live. PGDay here. Rotterdam, yeah. 20 to 5. Lowland is live. PGDay here.
Okay, so before introducing the next speaker, let me let you know that the music that you're listening in between presentation is actually made by somebody from the community. So please thank Thomas and Dave, who made this song for PGDay Lowlands. Yep, Dave is there. All right. So our next speaker is also, again, I'm lucky that good friends of mine are presenting here. She is person that also loves to go to museums, musea actually, and she enjoys some time here in Rotterdam. Yesterday, visiting a museum. So Rotterdam is a very nice place for looking at art and many things that are interesting, photography and all this kind of stuff in museums. So also, if you're staying here in Rotterdam a little bit longer, take the opportunity. But today we are going to continue with our nice talks about Postgres, and we are going to see the anatomy of the logs in a table that are going to be presented by Gulçin Yildirim. Thank you.
Hello. Thank you, Boris, for the nice introduction, and thank you, everybody, for organizing it. And I'm really happy that in the morning we have a full crowd. It never happens, as Jimmy said. I was expecting few people, and so it's like really dedicated conference people. I really like the energy and also maybe the vibe with the music. And it's nice to see so many friendly faces that are, long-time friends and also new faces. So I'm happy to meet everybody. Okay, so who am I? I work in a company called Zeta. That's how we pronounce it. But I think it's in Spanish. They can even say it like chata or something. So there are multiple ways to read it, but we say it Zeta. I don't know. It's a Postgres platform. You can check it out. And I was recently recognized as a Postgres contributor as well. I'm happy to be one of them. And I live in Prague, and we organize Prague Postgres meetup with a couple of friends. There is Major here, and there is Tomasz taking my pictures. So if you ever happen to visit Prague, we regularly run this meetup over 8 years that I'm involved, and it was even there before. So if you ever want to make a reason to visit Prague, just use this as a I'll just go to this meetup. And I also run a community over, 12 years, I think, maybe 13 now. Called Kadın Yazılımcı. It directly translates as women devs in Turkish. And we run our own conference. It will be the 4th time next year. It's called Diva, where we actually bring people who are from different fields and academic and also other industries and other fields of software technologies to talk about how AI actually change in the way that they work and what kind of inventions they come up with. So we actually understand what happens in the databases, the front end side of things, the whole life cycle of our jobs, basically. I think, yeah. And again, if you want to visit Istanbul next year, that's also another reason. Soon we will open the call for papers for English as well. So anyway, so let's start. As Boris was saying, and we really didn't coordinate with this, but I was in yesterday, I had a free time, and he knows me well that I was, going to the museums a lot. So I only managed to fit in one museum, Kunsthal, if I'm pronouncing wrong, I don't know. And they had really nice exhibitions, and one of them I also see an elephant, and as we always find elephants, I always see elephants everywhere. It might be, some bias, right? We know. And it's really good, and I'm really happy to be here. I had really good food and really good coffee, which are really main criteria: art, coffee, and food. And Rotterdam checked all the marks, and also great crowd for a conference. So happy to be here. And what we will talk today, it will be about, there was the survey that Jimmy mentioned that people really would wish vacuum away. And one of the reasons that we have it is also comes with MVCC architecture, which we will talk about it soon. And main focus will be about why we actually log and how Postgres logging works, specifically for DDL logs, and how we can actually reduce this impact. So you will see the examples of some queries and how we can make things better for, reduce this impact and reduce the log contention. And at the very end, last 5-10 minutes, we will talk about an open source tool called PGRoll, which I helped develop in the company that I work for. And yeah, if you try it, please let us know. Okay, so why I started to think about this topic, because when I joined Zeta, I was going through their open source projects, and that one of them really like interested me, the PG role, because it's kind of the message or the motivation is to make schema migrations near zero downtime with, and some people end up in the with the logs. And how can we avoid people to fall into this? And I was thinking, okay, I should actually maybe explain. Think about it a bit how Postgres logs work, and I wrote a couple of blogs about it, and then it became a talk. But when I was writing the talk, and I'm known to be postponing my talks writing, and then I was like, okay, maybe I should read books about logs. So I bought lots of books about Persian logs. I don't know how to do log picking, and I just like enjoyed a bit of reading before actually think about Postgres logs. But one thing is, it's not really alike. Like this physical logs in the real world is about security. So you have some money, I don't know, some important things, documents that you put in a safe. It's just to secure it away. But in Postgres, it's all about concurrency, nothing about security. So that's didn't bring anything. But one thing is like I can draw similarities between physical logs that I read, the log picking especially, and how logs work in general in Postgres, that to be able to pick a log, you need to have understanding of how this inner workings of a safe or a log work. And then you don't really need a key to unlock it, right? That's the whole point about it. You just understand these tumblers and mechanisms and switch them in a way that it actually can open. So the same way, to be able to understand how logs work in Postgres, you need to understand a few things. That definitely goes back to the how concurrency works in Postgres. Once you understand it, you will probably understand the impact and how it works with the logs as well. Okay, so how does actually Postgres manages this? The one thing that is like, I think to avoid many of the logging issues, we have a system called MVCC, and it is not something specific to Postgres. There's a lot of database systems and other software systems using it. The idea is like, when you write the new copy, like when you write a data, you create the copies of it. So instead of updating the data in the same place, you actually create multiple copies. That's why there are like this multi-version concept in the name. And why do we do this? So that we can ensure that reads are not blocking writes and writes are not blocking reads. You probably heard this term all the time, and you look at the MVCC documents, this is what it comes. But actually, this makes Postgres really efficient if you are doing concurrent DML operation. This is how Postgres solve a lot of locking issues that can come with this problem. But even in this MVCC-based system, there are some levels of locking is unavoidable. You will still, reads may not block the writes, but they might still acquire lightweight blocks and the objects like, I don't know, database objects like tables, views, types, stuff. And the other complications will come from that you really expect a statement or maybe substatements maybe to take same level of locking, but they don't. So the subcommands will have different level of locks than, let's say, an alter table. It will not be always getting the same level of locks. And that's why I think it actually makes things a bit more hard to comprehend. So there is this like simple example. I think it makes it easier to understand this theory of it. And before we start that, I would like to maybe explain some of the stuff. So when, let's say, a transaction is updating data and Postgres is creating another version, but it still keeps the old version. And each of the row versions, that there are some system columns that it's included. They are, unless you search for it, they are invisible to you, but they are crucial for the MVCC to work. So two things that if you know, that's probably enough for this example. Xmin is a transaction ID that creates that specific version. Let's say when you update that, it's the Xmin of the new row that will be that created this version will be the Xmin of that transaction that updates the data. And then the Xmax is the one that actually deletes or updates the version. So if that is the older version, you will see Xmax there of the transaction that actually updated will be the Xmax of the previous version. And the example you see here is actually a reflection of how Postgres behaves in default isolation level, transaction isolation level that is read committed. So if you run this example in a different isolation level that you changed, you will not get the same result. So the explanation of this example is how it works in default. And how does it work? So every time a statement begins, Postgres creates a snapshot. And that snapshot has all the transaction IDs at that moment, latest committed transaction IDs, and then list of in-progress transactions. And so in this, let's start with the query, the first query. So there are like 2 transactions here. I mean, high-level transactions, I might consider them as like transaction 1 is 100, and then transaction 2 is 101, and there was a transaction before that actually had this data. So what I do is like I select a salary of the Alice, and I see it at 50,000. And so it's starting, it's get a snapshot for the select, and it sees it at the 50,000, right? And the rows Xmax is null, and that means that this is the current one, and Xmin before is 99. That's why it's visible to us because it was already committed. And then the second transaction that comes, that's the 101, and tries to update the salary from 50,000 to 60,000. And now, instead of doing it in place, right? So this created the other version, and the old version marked with the Xmax 101 because that is the one that is actually updated this, right? And then it created the Xmin 101 so that it actually created this version. And now, when the second transaction commits, if it commits, it will make the changes visible to any new snapshots that starts. But when we do now, I'm running another, before it commits, I'm running another select, and I still see salary 50,000 because 101 is not committed yet. And after transaction 2 commits, I'm running the third select, and then it again gets a fresh snapshot, and there now it sees the committed transactions. So now the salary is 60,000. Basically, this is how it actually simply works, and that's why we can actually serve different things, right? The queries who are actually seeing the old version, they can keep running it, and then now we can also operate with the version that we want. But of course, as we like seen in the Jimmy's brief as well, these dead rows will accumulate until cleaned by a vacuum process. And that's why it's really important to tune like auto vacuum settings, and maybe we can do better there, right? I mean, it can be also, improved in Postgres itself. But that's why vacuum maintenance is essential for the performance. You don't want this. But yeah, if you finish with a good node, it's important that we have it so that we can actually have consistent snapshots for the long-running queries. And hopefully they won't run too long because they will have other issues. So we actually, without having excessive locking, we sorted a lot of the problems can come with the, high read and write workloads, and requires concurrency in Postgres. Okay, so clearly logs are not something that we would like to have, right? I mean, whatever the type is, it will definitely reduce the throughput, it will potentially increase the latency, and it means that also performance, nobody wants to have that. But if my intention is to make sure that my database, my data doesn't have corruption, and everyone is getting a correct result at their time of query, I have to have an agreement, basically. I have to log access when multiple transactions targeting the same resource, and I want to show things in the correct way. That's why we have to log. We can't really avoid it. And I think it's something to think, because there are like 2 extremes, right? There's a scenario that we never log, and then it's like a hell, right? Health can lose easily. We can all imagine it. And if we have to log for everything, that's the other extreme, then it will be pretty much impossible to work with unless you are serving one user that does at a time in one resource that doesn't have anything to, worry. But that doesn't happen. So we really have to have an isolation level agreement, basically. That's what we talked with read committed, but you can actually do different layers, different levels based on what you want. And that will come with this. Okay, so why? Because there are multiple types of logs in Postgres. Like I heard in PGDay Austria last week that Lawrence Albe is actually inspired by this talk, and he wants to do his own version of anatomy of row level logs, because that doesn't cover, this talk doesn't cover that. Hopefully Lawrence will, I'm sure he will cover it very well. And my focus was DDL, because that's what happens, right, when I run an alter table, when I have a vacuum full, that they require often stronger logs. And the one that we are trying to avoid is the access exclusive log. And maybe people don't really think that some operations, okay, they can assume that it will block the other DDL commands, it will block DML commands, and some of them actually select. So it means that the access to table can go altogether. So you might have downtime. So this is not maybe considered every time when you are planning these things, but it's something to think about. And we will talk about it soon. Okay, and also before we go further, I divided the presentation with like this little kind of, let's say, checkpoints or milestones. If you don't take anything within these pages that I talked before, you can just take these notes with you. There are like 8 of them or something. They are like more simple information. So first one is very clear as we talk. MACC protects you from write blocking reads, but not we can't totally avoid the locking. We have to take it, and some different variants of the same commands may require different levels of lock strength. And these are all the table level lock modes. I colored them from the kind of least restrictive to the most restrictive on the bottom. And the ones that are related to DDL is the ones that I marked is like purplish pinkish, because before there is like DML queries and selects and so on. So they are not really focus of today's discussion. So you can just look at the few examples. These are not definitely an extensive list. So there are like, if you want to see what statement gets what log, you can actually go to documentation and find it. It's not maybe the most straightforward thing, but it is there. And maybe more important than this list is like how these log modes interact with each other. So how, let's say, for example, share update exclusive. This will conflict with share log exclusive log, and access exclusive log. But it is not really straightforward. You really have to see how they operate. So there's a matrix in the documentation. You can look at it, how they conflict or interact with each other. Okay. Yeah, that's the first point. Basically says that it's more important how to see the conflicting between each other. And there are like maybe a few things to understand that from the previous page and here. And access exclusive will conflict with everything. So it means that it will conflict with the access share, which was the least restrictive log, but that means select. So it will block the selects, and that's really what we are trying to avoid. Of course, Postgres is not stupid, right? It has lots of optimizations. If it can take a weaker log, it will take the weaker log. It will, like, if it can, it will do this, but it's not perfect. Sometimes you really have to take the strong logs on some DDL operations. You can't avoid it. But the last point here is an important takeaway, because it says once a transaction takes a log, it will hold it even if the statement has finished. What does it mean? Let's say you have a transaction, and in one of the statements you have to take an access exclusive log, but then you don't really you do some updates, for example. The first one is an alteration. It needs this access exclusive, but the updates would be doing with a lighter log, let's say. And if you put them in the same transaction, you will unnecessarily hold this log during the whole transaction length. So thing that is to take away from here, separate these things. So if you are doing don't mix the commands that require strong logs with the others. So if you are doing table alteration and data updates, separate them in different transactions. So there's one way to easily minimize blocking, because you don't really want unnecessarily the end log to be held for the whole transaction length. You don't want to do that. So separate them. Don't put them in the same transaction. Okay, so how actually Postgres log queue works, right? This is how it's handled in the Postgres. So there's a locking queue mechanism, and let's kind of try to understand this easily. So let's say a transaction that wants to acquire a log, and it's already conflicted with some other log that is there's a log already held by another transaction, and these two are conflicting. Then the waiting one will enter to the log queue. And so catch here is that by default, this requesting transaction will wait indefinitely until this log becomes available so that it can actually acquire that log. And it is really, I don't think, known by everybody that it can actually become a big problem if you don't set your log timeout accurately. So set it so that you know that you will not end up waiting forever if this happens to you. And so these waiting logs will form a queue, and again, it's not unfortunately visible directly in the PG log system view. You have to use this PG blocking PIDs function to see which backend is blocking a specific backend. That I think could be also improved, to be honest. And the other part is at the very end, the logs that are ahead in the queue can block the logs that are behind them, and this will make a cascading delay, and that's really how the log contention happens. That's the state that we don't want to end up with. And that's like what we will see in the example that I will give later on. But yeah, takeaway from here is like set the log timeout, if not for everything, or except at least for the DDL ones, so you don't really end up in this state when you're trying to just change a table, alter a table. And for DDLs, you have actually a bit of more control, I feel, because the applications usually don't really, rarely run, I think, DDL. There's either a process that you do these migrations or vacuum or maintenance. So there are either workflows that you set for them that you are in control, or somebody does these things. So if you at least set log timeout for these statements, you're already, I think, more secure. But then, of course, it comes with also some catch again, right? You had the log timeout and some things will time out. And what will you do then? You have to handle this gracefully. So you can have either, some rollback thing or retry this again later. So you need to think about that too. Like setting log timeout will not actually maybe make you happy in the long run. It's still better probably than the other case that you don't set it and then things wait indefinitely. But again, you need to handle these errors that you will get if you set the log timeout. Okay, so this is the example, and it makes it much simpler. From now on, we will see queries, and I don't know how it makes you feel, but it makes me very happy. We can just talk about the queries instead of the other things that we already talk in the high level. So imagine I put an example here. There is a long-running select, maybe runs once a month. A department is running a long query. Everybody thinks that that's okay. Yeah, we know that it will take, 30 minutes or something every month. But then I am trying to run an alter table detach partition, very particular query because it's a real example. And that needs a brief access exclusive log. It will take this ideally, but it can't take the log because this will conflict with select that is already holding the log. So we can't really operate here, so they conflict. The alter table will be placed in the log queue. And then another 20, 30 backends that are trying to do simple primary key lookups, basic selects, and they conflict with the alter tables log. So they have to go behind the alter table operation as well. So what are we in the state that all access to this given table is now queued behind, no processing is happening until the long-running select that looks like normally innocent to people, that finishes, and then the alter table finishes, and then we'll able to operate we will be able to serve for the other selects that are queued behind of both of these things. So this is not good, right? So it's like it might significantly impact the performance, and that's why it's important to set the log timeout, definitely. But I think it's also a message that we should be mindful of long-running transactions, especially before you run a DDL command like this. You need to have an understanding of what's happening in your database before you actually do these operations. Yeah. That actually brings me to takeaway 4. Any long-running query, doesn't matter the type, it might be just a simple select that happens very rarely, can be actually important during the schema changes. Be mindful of them, look at it, and set the proper log timeout values for them. Okay, and so far we always talked it as if logs are unavoidable. In many cases they are, but there are things that we can actually, simple techniques that are not invented recently, they were all in documentation, but this talk brings them to you to see how we can avoid some simple strategies to reduce this log contention that you don't end up in the bad place. Okay, so first thing is really simple. If there is a concurrently command that is working with your statement, use them. Because what I mean, for example, creating index concurrently, I think pretty much everybody knows in the room. Or in the other example, alter table detach partition also has a concurrently. And if they used it, it wouldn't end up in the critical state because they were having a script. This was a very big payment system provider. And they were doing this detach partitions regularly, but then something changed in the script and they forgot to concurrently, and that ended up in a bad situation that it was an S1 ticket escalated to everybody in the company that I worked before. So it's like it can happen. So if they had the concurrently, they wouldn't end up this issue. But of course, this is not like a, set the concurrently and forget about it. That's what I mean. Of course, there is like, some, when you decide something, the cost comes with it. They will be definitely they will take longer to complete. And these are also not transactional, so means that you can't really put them in a transaction block and they can't really roll back because of this, right? And they will require better care, let's say. It's not as simple as like, okay, I run the concurrently, I'm done. Because inside of the Postgres, they will be run by different transactions. So they might actually, there's more risk of things not ending up correctly. So they might leave like, I don't know, partial changes and then have some failure in some place, and then you'll have to monitor them. But there are commands, like for example, for this detached partition, there are commands like finalize, so it can clean up or finish the work. So no need to worry, you use these things, but be aware that you need to treat them a bit more care. And maybe I want to talk a bit like if we run the detached partition concurrently, how would it work? Without concurrently, so basically there's a main table and there's a partition that we are trying to do this detach operation. The both main table and the partition that we are trying to detach will take access exclusive lock, both of them. And basically that means that the main table, while this partition is being detached, will not be accessible. And also the partition itself will not be accessible to do even reads or nothing. So it's total loss. And then if we were running this with concurrently, we would use 2 transactions internally in Postgres, and then it will actually minimize the locking impact pretty well. The first transaction, it does like main table and the detached part table that we are trying to detach, none of them will take access exclusive. They will take share update exclusive. That means that it will allow the reads, but of course it will block the schema changes, which you don't want it. You don't want to add and remove columns while altering this partition. It will not allow this to do this. And the same with partition. Still, partition will allow the reads while it's being detached. It wouldn't, of course, it will block again the schema changes and so on, but this is already better. And then after this point, after this transaction completes, this is marked as like undergoing detachment, and then Postgres wait other sessions using this table to finish, and then it will start another transaction internally, and then on the main table, we will still not get access exclusive in that transaction. We will still get the share update exclusive, which is better. And we will take in the partition one when in the second transaction access exclusive. And that's needed, right? It still has to take it, but the impact of it is much less reduced. It will not bothering the main table at all. And then it just finishes that and adds a check constraint to enforce the partition rule and is done with it. I think it's super smart, and this is one of the optimizations Postgres have it. So let's benefit it and use it. Okay, so now other things. We said about use concurrently. What other simple strategy is like, if you can break down the large DDLs into smaller and less blocking steps, you can use it. So let's imagine you want to add a not null column with a default value. And so we know that if we run this first statement there, alter table, my table, I'm trying to add a column with not null, and the default is a volatile function. That's why it is taking this. So this will require an access exclusive lock for sure, and it will rewrite the entire table, and for this whole table, there is no access to the table. You don't want it. And it can take, I don't know, based on how big, it can be minutes or hours, depending on how large the table is. So instead of doing this, let's separate it to the 3 steps, smaller steps, and see how it works. So first, I'm adding a column that is nullable. I don't add the not null here. I'm adding with a default again. It's the same function. Then in the second step, I'm populating the null values. So I'm running my update as a second step. And again, ideally, you should run these things also in batches, because you really, again, remember, you don't want to end up creating long-running queries at all. So run this update in batches too. And then at the end, I'm adding the not null constraint. And what is the advantage of it? First advantage is the initial column addition that we had. Now it only requires a brief access exclusive lock. Otherwise, it will be much longer. And the data population, it'll be with the, since it's a DML operation, it goes to a different level of lock. It will be row exclusive lock instead of access exclusive at the same time. And it will actually allow the operations to go. And that's already is already much better, but we will see if there is a way we could actually improve this even further. Okay, so in the last step of the previous query, we still added the not null like this in the first line, and then it will still take a long time. It will still block the writes while this is happening, but of course it's an improvement because it doesn't block the reads at least. So it will be already shorter than the original one. It does only one table scan. But anyway, so we can actually do this much better, and we leverage here check constraints. So what do I do instead? So I'm running an alter table. I'm adding a constraint, check constraint, but I'm adding it as a not valid. And then I'm validating the constraint in the second one. I'm running alter table, my table. I'm validating the constraint here. And this scan during the validate constraint is not blocking the writes. Why so? Because it actually only cares about when it's validating, it only cares about the data that's already in there. And when you are adding the check, when you edit the check itself, it actually only cares about the new ones. It doesn't care about existing data validation. So it's already a smarter strategy. And then at the end, you have to add the not null on the column, right? Instead of the check constraint, you have to do this. But now Postgres is really smart because it's aware that is actually what it needs to be done is done already. So it's a simple metadata operation. There's a valid check constraint. Postgres understands it, but of course it will still take a brief access exclusive log to do this. And then you remove the check constraint. Now it's redundant, obviously, and then you are done. So the strategy is that we managed to divide how we treat the new insert, how we treat the inserts, and how we treat the data that we already have. And that's how we did it with the invalidation and then validating it later. Okay, so the takeaway 5, and we are in the, I think, later parts of the presentation. Try to find an approach that does the less locking, and that will definitely need some expertise. And if there are tools can help you do this, also we can use that. Okay, and another thing, remember the query of the adding not null query. And before, if you're using an older version of Postgres, running this like add column not null and default with 1, you will be still treating it as like the query that we run with the function volatile function, because now Postgres is smart. Now it executes very quickly if you're running in a modern Postgres version, because it can see that it's a constant value, and then I can store it as a metadata, so I don't need to rewrite the whole table for this. But if you are using an older Postgres version, it will behave the same way. So that brings me to the new takeaway. If you can, and if you are able, and if your organization allows you to do that, promote for upgrading to modern versions of Postgres. And I was asking in Switzerland this year, and there was like people who are running Postgres is between 8 points. I don't know who is running older than 8. Is there anybody running older than 8, like 8, Postgres 8 here in the room? Redshift. Oh my God. Okay. Maybe 8.5, 9. Is there people in the Postgres 9? That's a modern room, definitely. Like, because in Switzerland, I was like 8, and this actually, it's also good, right? We know that Postgres can still run on the older versions. It's amazing to me. Like when I started Postgres, it was like, yeah, I was running version 8 too, but it was a very long time ago. And I'm happy that people can still operate in their production systems with these versions. That is also a nice thing. But if you can basically avoid it, you can avoid it. And yeah, use the optimizations that are already included. Okay, so we are almost at the last part of the presentation, and I will do, let's say, a bit of plug, as Jimmy was saying, the project that I'm working, PG Roll. And the motivation of this tool was like why they built this tool before I joined. They want to have log-free migrations. They want to handle the data backfilling that happens, right, as we see there are updates happening. And there was also a big problem in the customer base because people usually, when they plan schema migrations, they have kind of like playbooks for it. Like, okay, this application will be stopped, and then you need to run this operation. And then if things go back, there's this rollback script, and there's steps and steps and steps. There was a famous company with like lots of steps for how to handle the schema migration. And it shouldn't really need to be this way if we can actually avoid it. But there was also the way that there's PG role work is also designed to have multiple schema versions at the same time. So basically, there are like 2 versions of your schema active at the same time of the the migration that's happening. So there's the old schema and the new schema. So that means that old versions of the client applications can coexist with the new versions of during the application rollout, because they both see a different version of the basically database schema that they expect to see. You don't really need to do it this way, right? Schema migrations doesn't need to be this way, but this was designed basically to handle people to do kind of blue-green type of deployments, the like application rollouts without downtime. And that's why it was built the way that it was built. So that's why it has the schema versions, multiple schema versions. And this is like a choice that I was not basically understanding at the beginning, but instead of writing the direct SQL, we do in PG role with the high level operations. So there's an add operation, I don't know, add column operation, change type operation, and so on. And before it was like with JSON. When I joined, we made it with default YAML. I think that's more usable than JSON. Maybe for the people in the room, they would agree. It's not for developers, perhaps, that are used to modern, I don't know, JavaScript way of writing things. And then also we have the spec link of data. You can also define it here. How do you want this thing to be operated? But the idea is like, let's say you are adding a new constraint, not null constraint, let's say, and you add this, and the new versions of your application wants to have this constraint. So if they are trying to enter null data, they will just say, okay, hey, you can't enter null data, but you still also serve for the old versions of your, old versions of your application that also is able to enter null data. So what happens? So we transform this null data that comes from the older version in the new table setup that we want the new applications to behave, because they want to have the constraint. And that's how we do transformations. And this is what it's like up and down. So both ways are kind of aligned, and you can define how they should be in the background, so you don't need to worry about it. But I like this picture pretty much, because do you see this middle red area? You start the migration, you do the rolling upgrade, and at this red spot, they are both running simultaneously, the application versions. And you can keep this as long as you want. You can test stuff. And if you are happy with what you tested, you can actually move on and continue and finalize your migration. That will be the new version. If you are not happy, you can roll back. Because there are a lot of schema migration tools out there. Not many open source, I think, but there are a few. But the people, like the enterprise or, I don't know, closed source tools, they treat rollbacks as a premium feature. I was very surprised. I mean, what is the point of this if you can't even roll back? Because maybe in their design, it's not designed this way, and they recommend always roll forward. And rolling forward always is not really, I don't know, you will end up with the things that you not necessarily want to have, and then you will work around it instead of you could actually here roll back. I think that's like what makes it kind of unique. If your type of migration is like blue-green type of migration, that will be useful for you. And yeah, so basically until migration is complete, you can serve both versions. And this is how it looks a little bit. We are using some pattern called expand and contract. That is also not something new. It's a software pattern. What does it mean is that you expand the table, you add this in the physical table, that you add these things that you want to add, and then you do the migrations, and then you contract. So you drop the things that you don't need anymore. That's why it's kind of expanding at first and then contracting later. But people, like from the same table, right, we have different views. That one is like seen by the older version of the apps, and the other one is seen by the newer version. So you have double of the views from the schemas, that different schemas point at a different version of the view, and that's still attached to the same table. And then you do this manipulation by setting the search path to point at the schema that you wanted. And we already talked about, we handle the spec filling automatic. And good thing is that you can actually control this, because remember, I wanted that if you do the updates, you need to do it in batches. And we allow you to do basically define the size of the batch and the rate of the batch processing and so on. So that's also, I think, beneficial. Yeah, this up and down migrations and the data spec filling happens with the triggers. But anyway, if you want to do it this way, you have to have this data backfilling sorted somehow. Maybe the good thing about is that now all this logic is out of the application and it's more closer to the database layer. That's also very convenient because we all know that, you know, schemas are not static things. You don't start your database, okay, these are my tables, these are my columns. I will never have to change anything. I will never have to add an index. I will never have to change the type and so on. So we need to plan for it. Like schemas are evolving, living things, and like databases and applications and the users of this. So it's important that we can actually handle the migration story. And remember, there was this log timeout discussion. We actually generate the alters prefix with the set log timeout so that you know that you will not end up in an indefinite time of waiting in case there's a log occurs. And then we also have the trying again logic included. Okay, so this is it pretty much with the PG role. And yeah, if you try it out, let us know. I would be really happy. I individually read all the issues that are opened, all the PRs that comes. So really happy to see activities after conferences. I can see that, you know, people are actually looking at it. It makes me really happy that I actually, you know, the talk actually reached some people who might actually benefit from it. And yeah, if you are using, mainly I think what I need from the people in the room, if you are using a specific ORM or different way of handling these things, I really like to know basically how do you perform the schema migrations? What is your developer environment look like? Because based on that, things can change, right? Like because we have like commands like convert or something to transform this ORM generated SQLs to the PG role operations, but it's not always very simple and not everything tested clearly. So I will be happy to see different ways of how people are using it. And I keep blogging. And if you are not following Planet Postgres, please follow Planet Postgres. There's a blog aggregator, and it collects all the blogs that we all write from the community members, most of us at least, and big companies also blogs there. So if you are not following it, follow it. And I really learned a lot from that. Yeah, dankjewel. I think I really overused my time. Boris was like, no.
So, we are going to have Gulcin. You are going to stay here the entire day, right? Because
Yes.
you want to answer questions during the break or during lunch or whenever you find her, she's going to answer all the questions that you have. We also want to give her our beautiful handmade keyring. If you want to know how this was made, we have published on the social a video about how this thing was carefully crafted for our speakers. So please, round of applause for Gulcin once again.
Thank you.
So to catch up a little bit with the break, we still want you to have a good break, but instead of doing it half an hour, we are going to do it 25 minutes. So be here back at 11. It's good. We're starting at 11. Thank you.
20 to 5, low end is live. PGDay here, Rotterdam, yeah. 20 to 5, low end is live. PGDay here, PGDay here, PGDay here, PGDay, 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 PGDay here, Rotterdam, yeah. 20 to 5, low end is live.
Welcome to PGDay Lowlands, Rotterdam 2025.
PGDay, 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 PGDay here, Rotterdam, yeah. 20 to 5, low end is live. PGDay here, Rotterdam, yeah. 20 to 5, low end is live. PGDay here, PGDay here, PGDay here, PGDay, PGDay, PGDay. PGDay, PGDay here, Rotterdam, yeah, 20 to 5, Lowland is live.
Welcome to PGDay Lowlands, Rotterdam 2025.
PGDay, PGDay here, Rotterdam, yeah, 20 to 5, Lowland is live. PGDay here, Rotterdam, yeah, 20 to 5, Lowland is live. PGDay here, PGDay here, PGDay here, PGDay, 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 PGDay.
It's going to be given by our friend. I cannot pronounce your family name, but I know that Joseph is your first name. Joseph is not just a very strong technical person. He also has a very good love for psychology. So it's one of his long life hobby to study psychology. And that's why he's going to be a kind of like a therapist for databases in distress. This is going to be kind of like a healing of the trauma of the databases, right? So please welcome Joseph.
Yes. Oh, thank you very much. I am really glad to be here. This is really a conference to remember. I like this environment, so I want to thanks for the opportunity to give the talk here. And I will be really talking about database in distress and, of course, people in distress around crashed database. I work for a German company, Credative, and we do support for open source products, and Postgres is one of our biggest topics. Here are a few information about me. I have like more than 30 years of experience with different databases. I worked for different companies and also for some very interesting startups. So I could work with very interesting environments and interesting technologies. I am originally from Czechia, but now living 11 years in Berlin. First of all, there was already Simon Ricks mentioned in the first talk. I want to acknowledge that also I was inspired by his talk given in Prague, and he used these words. He said that we still need to ask stupid questions because we could be, satisfied that Postgres is number one, which means we are the best. And he said, this is not true. It just means that it's number one. And he says that new users are asking questions, and those are good questions. So we need to ask questions about everything. And this is why I embarked on this talk and on this research, because I wanted to understand corrupted databases in more technical details. But I must also acknowledge that there are already some amazing talks from previous conferences and some articles, and I built on them, because without these talks and these articles, my talk would be looking differently. So I strongly advise look at those talks, and you will find a lot of information there. I will just dissect now some things in more details to show you how is it working behind the scene. First thing is that Postgres is actually remarkably stable. If you run Postgres on Linux under typical circumstances, it is rock solid. Almost all of these databases I have to repair were on Windows, and yes, sorry about it, but it is as it is. And in one case, a badly crashed Kubernetes cluster damaged the data, so it was a situation on Linux, but created by Kubernetes. And what was important in these all cases, those companies did not have no useful backup, any useful backup. Problem is that some types of backups can mask corruption. I will talk about it. So we have these block checksums, which are available for check of data corruption, but in Postgres 17 and older, they were not enabled because of performance concerns. And without these with these checksums, many types of corruption remain undetected and are revealed only when you read those specific records. So this is why often those corruptions are shown when you try to do PG-dump backups. Because a PG-based backup actually copies data as they are, the whole files, and it does not check data integrity. So you can have years of backups done by PG-based backup. They could be all corrupted, and you may not know it about it. So when you try PG-dump, and it was the situation in all those cases when they try to do PG-dump, and they have seen something from these errors. So First of them is invalid page in some block, which is like situation which is usually seen in this like most common. And second most common is this could not access status of transaction with some ridiculous number. I will explain how they actually happened. And if you have a damaged sequence, there could be problem to read data from that sequence. And in some rare cases, corrupted data can even crash the session. So you get memory segmentation fault, and that session crashed, and postmaster must restart all those backends because shared memory could be corrupted. Very often, that corruption is hidden in older, rarely accessed records, maybe in even frozen tuples, because they are not visited by auto-vacuum. But even if auto-vacuum fails on some corruptions, you may not notice it because you can have millions of records in log, and one of them is error from auto-vacuum. And this is what I was discussing with that guy who is actually developing PG Weasel log analyzer. Sometimes one error in dozens of gigabytes of logs is more significant than millions of errors. And this is exactly this situation. So I said that PG dump can show what corrupted objects, but problem is that this will end on that first corrupted object which is found. So when we analyzed those corrupted databases, we used this script in PowerShell, which generally reads all databases, reads all relations from each database, and tries to dump each table separately into a specific file and logs those errors into logs. So if we later see those error logs which have some content, we see that these objects are damaged. This is like first sanity check you can do on your database to see how many really damaged objects you have in a database. And we have now pluggable access method for storage of data, but heap is still default, and all databases have been created using heap tables. So to understand what is happening, I created corruption simulator in Python, which surgically damages different parts of data block to give me precise behavior when some types of corruption happens. And this is what I will now show you. But first thing first, checksums. I already mentioned those checksums. We have them, we don't use them. Fortunately, in version 18, they now set checksums as default during initdb, which is a great step forward, and you will understand why in coming slides. This is that commit which actually did it, and there is also this ignore checksum failures parameter which controls that error handling. So how it looks like when you have database with checksums and some corrupted data. Here it is. Checksums are calculated for each data page, and they are stored as 2 bytes in the header. You will see it in other slides. And when Postgres reads data, it calculates checksums again and compares them with the stored value. And if there is some error, it will show that error which we already seen, invalid page in some block. That ignore checksums failure setting is default off. So by default, when there is some checksum error, that query will stop on first block which is corrupted, meaning which has different checksum calculated from checksum stored. But you can say ignore checksums failure on, and then it will report all those pages which are actually probably corrupted, but it can still exit on some other transaction. And this is usual situation. This could not access status of transaction of some huge number. We can easily cure those pages which have bad checksums using this zero damage pages setting. Default is off, and if default is off, then it will behave exactly the same way. It will end on first error. If you set it on, then it will not only skip those damaged pages, it will also zero them out, meaning we will lose content of those pages, but that content is lost anyway. I will demonstrate why. So if you have checksums, you do not need to be worried about any types of corruptions because it will be always shown as a different checksum from what is stored. So I highly recommend if you will install new databases with Postgres 18 or even with 17, allow checksums, because especially if you run something in a very violent environment or on Windows, then it will help you definitely. But I also must mention that all those blocks which would be zeroing out, there will be lost. If you set those zero damage pages to off, again, it will not restore original content. But you must understand that it will zero out only those pages which were read during that query. So to zero out all damaged pages, you need to make sure that you read all data pages from that table. And after this, let's dissect data corruption on that low level of that data page. So, as I said, the heap access method is default, and here is the anatomy of data block, how we know it, how we love it or hate it. It's up to us. So there is this page header, which contains metadata for block management and integrity. Here are those item IDs. Here are tuples, and here could be special space, for example, in indexes. So when we add new record, item ID is added here as first after that header, and new tuple is added here at the end as first. So this way we go backwards, and that item ID stores position when that tuple starts and how long it is. So if we now corrupt some parts, we get a different behavior. If header is corrupted, then the whole page is lost. And without checksums, actually, Postgres can detect only corrupted header. And I will show that part of code. If those item IDs are corrupted, then we have no access to tuples. And if tuples are corrupted, then we will have ridiculous content in system columns and also in normal columns. So let's look at it, how it looks like. This is header. It occupies first 24 bytes of every page. It has these important values, and we can detect without checksums only like obviously damaged values. This is this part in code. I looked on release 17 stable and release 18 stable. Here you can see files and names of those procedures. And pay attention to this comment. Actually, there are many interesting comments in code directly, which say much more than documentation. So if you are looking for some problem, I highly recommend to go into source code. And what it says, following checks don't prove the header is correct, only that it looks sane enough to allow into the buffer pool. So without checksum, it's sort of a guessing game. You know, we can only say if those flag bits contain valid values, if these parameters for offsets and block size fit into version or into numbers which we expect. So if it fits, we say, good, it is probably not corrupted. This is all we can say without checksums. We can say the data are probably sane. And here is explanation of those special bits. This is not that important, but let's look what we can actually analyze. We have several extensions, mainly page inspect. At healthy header, you will get something like this. Important things here are those offsets and where that special part begins and page size. If that header is corrupted, meaning it was rejected by this test, then we cannot analyze anything. We always get this invalid page error. If we set 0 damaged page on, then page is zeroed out, and we will get only zeros. Everything is lost. Okay, this is corrupted header, but as I said, it's still like the best option from those corruption if we don't have checksums, because we can detect it. We have other types of corruptions which we cannot detect and which can even crash the session. So here is corrupted item ID array. These values saying us where tuple begins and how long it is. So if we take page inspect function, heap page items, we can see how healthy page looks like. What is important here are those offsets and those lengths of those tuples. So first tuple begin almost at the end of the page, and every subsequent tuple is closer and closer to the beginning of the page. And here you can see different lengths of those tuples because there are some text contents, and therefore content is variable. This is healthy page, how we like it. We have here transactions which created those tuples. Here is CTID. Everything is perfect. What happens if we surgically damaged those item IDs? Yeah, this thing happens. You can see we have 8 kilobyte page, and we have offset 20 kilobytes. We have offset 17 kilobytes. And what we have here, length of that tuple, 28 kilobytes. This is how memory segmentation fault happen in the code. Because we can get two typical errors: invalid memory allocation request of some absolutely ridiculous size, or process was terminated by signal 11, and then you will see in Postgres log that there was memory segmentation error. This is how it happens. Because code tries to interpret these ridiculous values without checking for page size. And if we try to analyze it, yeah, I already showed version from page inspect, but what about AM check? Yeah, well, unfortunately, AM check is not helping here exactly because these messages are quite cryptic. You know, I spent, some time thinking about what was the motivation to do this cryptic message. But problem is, AM check is taking those ridiculous numbers seriously. It does not flag them. It does not say that it is impossible in page which has 8 kilobyte size, So this was corrupted item ID array, and now let's look at situation when we surgically damage only those tuples. So we have header intact, we have item IDs intact, and we damaged only that part with tuples. As we know, each tuple has its own header. And most important values are those transaction min, transaction max. There is also CTID stored, and there are some info masks. So if we look at healthy page, it looks this way. And here I used a page from Toast table because it has a very nice structure. Usual situation in those table is that data page has 4 records, each 2032 bytes long, and therefore everything is quite ordinary, everything is directly visible. So we have here 4 records in those table in this particular block, created by one transaction, CTID is perfect, everything nice. And when we damage it, what we get? We get this rock and roll. And this is where those strange errors, I cannot check status of transaction, where they originate. Because here are these ridiculous numbers, and we take them seriously. You can see also absolutely ridiculous numbers in CTID, and we also take them seriously. Because we somehow don't, think about situation that those ridiculous numbers could be product of data corruption. Because we say, okay, header is okay, we can read tuple, so what we find here is probably true. No, it isn't, because it's just damaged content. Because if you have damaged tuples, you have absolutely random content. Also, you can see those info masks are damaged and also these offsets. And here, Postgres actually crashes. And unless you do surgically deletion of those tuples, you cannot use that table. So let's look what we can do with this. Here is also when you select from that main table and only tuple table is damaged, you will see additional errors, which are all created by the fact that those table is damaged. Because it cannot find some chunks or unexpected chunk numbers and so on. And again, those are ridiculous numbers from corrupted tuples, and we take them seriously. So what to do with corrupted tuples? We have this nicely corrupted page. It's absolutely useless. It ends with that error that there is some transaction ID which we cannot check. So we can use PG surgery, and here is this heap force freeze, which will, as I said, freeze data. That function requires CTID. But you cannot use this broken CTID because it does not do sequential scan for CTID's values. You must actually estimate what is the right CTID on this page. So in this case, it's page 273, and we want to freeze first tuple. So let's look again on that first tuple. We have ridiculous xmin, xmarks, and also other values. What happens when we freeze it? Yeah, well, record is frozen. Transaction min is 2. CTID is what we expect, but all other values are still the same. And when we try to read that record, it returns either nothing or some gibberish. So freezing of tuples which are damaged this way is not feasible. We must simply kill them, and therefore we use this heap force skill, which again requires CTID, and when we kill it, that record is gone. And that way, we would need to kill all those other tuples. What would be really helpful here would be some function which would kill the whole data page, because here we have 4 tuples. But in some situation, we can have like 200 rows in that page. So killing the whole page would be much more convenient. I tried AM check again, and here those messages are even more cryptic, because it actually presumes again that those values are okay, and tells me that there is some mismatch where tuple data begin, and it suggests that that tuple has, wow, 2,000 attributes. We have magical space in our database, 2,000 attributes. It wants to interpret those damaged data and gives these results without being ashamed, because those results are obviously nonsense. But yeah, this is as it is. So we must work with this. Only one page about corrupted sequence, because sequence is actually just non-transactional table with one data block and one row, and that row has those hidden system columns and 3 normal columns, and one of them is last value. So if that one data block in that sequence is damaged, you can either get this invalid page in block, or there are special errors in case of sequence, bad magic number in sequence. This is one of the most beloved error messages regarding data corruption. Bad magic number. Yeah, well, there are other magic numbers in corrupted data, but here we at least say. Yeah, and also this invalid memory allocation request happen here, and in some cases even that crash of that session. And when we try to select data from that sequence, it returns 0 rows. Okay, so I mentioned several times that memory segmentation fault. It is caught by postmaster. There are those functions which actually do it. And here is that part of code which then says that a process was terminated by signal 11. And this is it. There was some memory overflow, some segmentation fault in code. So what we really would need some low-level sanity checks, at least, switchable on and off, because I can imagine that in normal situation, it could have like bad performance impact. But if you are repairing damaged database, you would give like gold for such checks, So can we cure corrupted data? Well, without valid backups, original data cannot be restored. And valid backup is not necessarily binary backup done by PG-based backup. You can have dozens of PG-based backup all corrupted and not know about it. If you use that, if you don't use checksums, which is actually normal in these days, only pages with invalid headers are detected. We can zero them out, but we still have other situations when corrupted data blocks contain unpredictable values, and therefore we need to either remove surgically those tuples or do salvage row by row, which can be very time consuming. How this salvaging good data row by row looks like. I think you understand that it depends on particular data model, how those tables are built. Here is just one idealistic example. When we have main table with ID as primary key, and there is toast table, and that toast table is damaged, then we still can select those values of primary key from that main table, and then try to select row by row based on that ID, and if it is okay, insert data into that new table, commit after each insertion, because there'll still be that segmentation fault error, and that way we can really go row by row, which is amazing when you have table with just 200 gigabytes and one damaged data block, which is situation we had by one customer. So you can imagine that it takes hours, dozens of hours. So this is one option. What about table which is so badly damaged that you cannot even select consistently primary keys? Yeah, well, we can select using CTIDs. This is the only way how we can try to select row by row. But here we must know how many pages in total in that relation, and try to guess or find what is the maximum amount of tuples in data page. And then we can create dynamic query selecting using CTID really row by row, inserting those queries which are okay into that table where we salvage data. Again, it depends on a particular data model, so this is just some example. And we must commit after each insert, because that segmentation fault can happen quite often. And if it happens, we need to avoid these particular city IDs which actually cause that segmentation fault. As you can imagine, this is very time-consuming, labor-intensive, but for some clients, it was the savior. We spent like several days really restoring data which were damaged by some ransomware. Yeah. So these are like two examples how you can deal with it. And of course, what you need to remember, if you restore damaged data, then if data some are lost, then foreign keys might be compromised or most likely will be. So you either need to remove those orphaned rows from child tables or create some dummy rows in parent table to make those foreign keys consistent again. Of course, rebuilding indexes is absolute must. And if you have corrupted sequences, they can be only dropped and recreated. There is no other way. And we cannot be sure about their values, so we must set last value based on current data in that table, what is available in those primary keys. So what would help us to make those repairs of corrupted databases easier? Yeah, well, checksums would be the best, but absolute majority of all databases does not use checksums. We would really need some sanity checks in the code to prevent those segmentation fault crashes. This sounds, like Middle Ages. Like I read some bad data, oh, let's try to use them and let's crash on them because, users will understand it. Yeah, well, it's crazy. And as I said, for a normal run, those checks could have like really bad performance impact. But when you have really customer, in great shock and you try to repair data, then having this and having possibility to skip those pages, which actually creates those segmentation fault, or tell you, oh, there is some great transaction ID, like, I don't know, some huge numbers, and I am not sure what is the status of that transaction. Yeah, some transaction IDs are ridiculous by definition. Why we take them seriously, So we shall be able to skip, for the sake of repairs, these absolutely ridiculous transaction IDs, or messages like, there is parallel commit not committed, or there is multi-transaction ID not created yet, apparent wrap around. No, this is apparent corruption, and we need to skip it for the sake of repairs. And using this sort of, emergency mode, we would be able to dump data which are healthy enough. We cannot say that those data which we will dump are absolutely 100% clean, but they look healthy enough to be dumped. Without checksums, this is all we can say. We can say that page looks sane enough, or data look reasonably enough for us to use them. So this is like another testimony to using checksums. But as I mentioned in one of those slides, if you would want to add checksums to existing database, it means downtime, and it means also data checks, because it can create checksums of already damaged data, which, yeah, in some situations could be useful, in others not. So this is all what I wanted to show you. And if you have some questions or comments or whatever, please, now is your time.
Thanks, Joseph. And we have two questions. First, I'm going to give the microphone to Vic here.
Hi. Why don't we test for tuples too large and offsets too large before, instead of just segfaulting?
Yeah, well, as I said, Postgres is remarkably stable on Linux, and since it existed originally only on Linux, and people avoid, even porting it to Windows, I guess it was, in those days, was not necessary. But later, when we run now a lot of applications on Windows, there is software depending on Postgres running on Windows, like DaVinci video editor or some accounting software and so on. Or on Kubernetes, we are now encountering situations which were not happening before so often. So this is why I want to raise that flag, that these checks would be really nice to have, at least like switchable on off. At least this is how I understand it, and I hope that some contributor will actually say more about it, because I am unfortunately not core contributor, so I just analyze code and try to find what could be improved. Yeah.
Thanks. So there is another question here.
Thank you for a nice talk. A question about checksums, Postgres checksums on a checksum file system. Does that make any sense? Especially if it's going to be turned on by default now. If you run on a checksum file system, should you turn it off because it doesn't add anything, or is there still value in keeping them on when you upgrade to Postgres 18?
I only look at that problem from the perspective of Postgres. So I don't have enough knowledge to answer this, I'm sorry. But I highly recommend to use checksums in database, because it's like that first level of defense where you can actually immediately see if something is wrong or not. Yeah, so sorry.
Okay, thank you very much. So despite all those ridiculous transactions IDs and ridiculous blog pages that were corrupted, your content was definitely not ridiculous at all. So that's why we want to give you this nice key ring for you to show our appreciation. So thank you, Joseph.
Thank you.
And with that, we are getting ready for the next speaker, who is going to come to this stage in a few seconds. While he's coming here, let me tell you that we opened the feedback for the sessions and for the conference as well. So if you go to each of the session, there is a button there. If you click on the session, you're going to get either to the description, or you can also leave feedback immediately. So if you want to provide some feedback to the speakers, it's going to be very, very valuable. So Chris, while Chris is coming here, if you already visited all the sponsors that are in the Sharks room, then you will be able to participate in the raffle. To participate in the raffle, go to the registration desk. There is a beautiful box there prepared for putting your sponsor's passport, and then you're going to be able to participate in the raffle that is going to be giving very, very Dutch prizes at the end of this conference. Now, our next speaker, who is jumping in because we needed to change a little bit of the schedule at the last minute, he said that this talk is actually not a full 45-minute talk, which is a very convenient situation for us, because he's going to end at a certain moment in between his time slots. At that point, we're not going to start immediately with the lunch. This is time for you to go to explore a little bit the aquarium or the zoo. And you also wanted to prepare a challenge, because you have one of his major passions, apart from Postgres, is to build up electric elephants, like the one that he's wearing now, electric elephant of the PGDay Lowlands. Here, this beautiful thing that gives some lights when it's in the dark. So what is the challenge that you wanted to give to people if they have a chance to go and take a picture in the zoo?
If it's working,
Yes,
well, the idea was, we came up with this sort of in the pub last night. The idea is, if you go and take a photograph of an elephant and share it on social media, you can win the chance to win one of 6 electric elephants. There we go. If we finish early.
So if you want one of those electric elephants, take the time to take a picture. You come with your selfie. You can put it on social media, and we will see it, and you can get your electric elephant on the registration desk. But come back on time for lunch, which is going to start at 12:30 according to the schedule. That one is on time. But now let's enjoy the talk of Chris, who is going to talk about fun stuff with UUID.
Okay, so yes. So first off, I'm Chris. I'm from the UK, if that wasn't obvious. I tend to kind of go around calling myself a bit of an IT jack of all trades. I've worked on quite a lot of different projects over the years, from search engines to industrial IoT systems that throw conrods out if the control software goes wrong, fun things. And pretty much a common thread across all of that is I have used Postgres in pretty much everything. I've been using it for about 20 years at this point. And this talk sort of came out of a conversation that I had at a Postgres London meetup with somebody, where I was discussing that I quite like using UUIDs for primary keys, and he had the viewpoint that that was terrible and it's an awful idea and you should never do that. So we had a bit of a discussion and a bit of a debate. And I kind of expressed, well, actually, I think there's an awful lot of value from using the extra space in UUIDs to do fun stuff. And this is kind of where this talk comes from. So first off, what is a UUID? So I'm guessing a few people in the room will already know what they are. Most people will be used to seeing it in this format, where it's a 34-character string. So this is actually 16 bytes of data encoded in hexadecimal. So that's really all it is. It's a 128-bit number. It's nothing more complicated than that. It's just 16 bytes of data. But there is some special bits in there. So there are two nibbles. So nibble is 4 bits, which specify the version of the UUID and the variant. And if we look closely at this kind of big long string, we'll notice that this version field is a version 4 UUID in this particular example. And in this particular example, also, if anybody's good at remembering the ASCII table, you can work out what that UUID says. And in this particular case as well, we have this version 4 UUID, and this is also got a subproperty called a variant. The variant property varies based on all the different versions, so it's not consistent or standardized. UUIDs themselves have a whole bunch of different RFCs. They're not particularly the very early kind of versions that come from like the 70s and 80s have kind of been superseded, and the most up-to-date RFC probably that's used roughly everywhere is kind of 5962, which mostly focuses on specifying this particular version for UUID, which is what everybody uses because it's random. So if you use the function in Postgres to generate a UUID, gen random UUID, it's going to return you a version 4 UUID, which is basically 120 bits of random data. So how do we go about using these in Postgres? So it's not any more complicated than just a other column data type, right? We can use it just like we can a big int. So we can actually declare it as the primary key of our table. And this is an example from one of my systems where we have quite a lot of UUIDs and the primary key is a UUID. So this is absolutely no different to if we were using a big int or a big serial or a int or a serial. So that kind of leads me on to, well, what's the bad side of this debate? Well, a lot of that comes down to, there's a very simple point we'll start with, which is it's twice the size of a standard 64-bit integer, right? So you're going to use a bit more disk space. But realistically, 2025, not really a problem. However, what becomes much more interesting is all the problems that the fact that by default, or the most commonly used version of a UUID, is randomly allocated. Now, to a large extent, it's more the random allocation of the ID that causes the problems as opposed to it being a UUID. So to some extent, I want to kind of expunge the bad press that UUIDs get. It's not about that data type. It is not a problem with the data type. It's a problem with the most commonly used version. And it is a problem with effectively randomness. Now, the fact that your ID is random, it's then inserted into a B-tree index as your primary key. There's going to cause a few problems where number one is that by being randomly allocated, those different IDs are going to go to different pages in your B-tree index. So we end up with more index buffers that are in use at any one point in time than if it was a sequential ID, where in a sequential ID, it's going to consistently be appending to the same set of index pages. The other sort of trade-off with that is that you kind of lose the correlation between the ID and any form of temporal kind of locality. So if you're using a sequential ID, you pretty much guarantee that the higher the number, the more recent it is. And in most data systems, funnily enough, the most recent data is what's getting accessed most often. So by having our IDs that are randomly distributed, we kind of lose that connection between our ID having some connection to data that is most likely being used right now. And then there's another interesting side point where that kind of loss of correlation leads to certain optimizations in Postgres not working, because those optimizations are effectively trying to look at stuff in that kind of more linear way. So we're going to take a very simple test case to just demonstrate this problem. So we'll have a table, and in all these examples, the table structure is pretty much the same. We have an ID column, and we have a value. That value is just a text string of 500 bytes, just to create some space in our table. So that the idea here is we're just modeling. We have an ID and some kind of data in our row that's going to be usually fairly sizable. And we're going to do this with both a big int that's generated sequentially, a big int that's generated randomly, and of course, our UUID. So very simple test, very, very simple kind of setup and benchmark. And first off, let's just have a quick look at the size. So firstly, whilst our UUIDs are double the size, because we've, the ID itself is not really taking up a predominant chunk of the table, because that's actually our data that's taking most space, then we don't actually use too much more disk space when using UUIDs as primary keys compared to big ints. What we will see, though, is that the indexes are pretty much double the size. So our UUID index is basically double the size of our standard 64-bit index, which makes quite a lot of sense. At the end of the day, the actual physical data is double the size. What's kind of interesting is that the randomly allocated 64-bit integers are also bigger. Now, this particular test, I'm not cheating and creating the index after I've inserted all the data, so you get a perfect B tree. It's meant to model real-world kind of use cases where you create your table and then you fill your data in. So it's kind of interesting that obviously if we kind of do go and create the index afterwards, then even on random data, we can build more efficient indexes than if we insert data going along. But what becomes very interesting is if we take a very simple test case that we're going to use to kind of show the different properties of different encoding schemes. So we're going to just do an index-only scan. So we're going to do this by just doing count of the ID. And that's going to basically do a scan only on the B tree index of all rows. And we're going to use good old explain, and we're going to use explain buffers because we want to see the number of shared buffers that are hit by doing that index-only scan. So if we do that on our first example where we have a sequential big int, we look up about 27,000 buffers. So that's 8K blocks that Joseph's just been talking about. However, if we do that on our UUID example, we're hitting almost 2 orders of magnitude greater. We're hitting 9.5 million shared buffer hits. Now, this isn't necessarily going to slow stuff down always noticeably, but it is Postgres having to do an awful lot more work, having to constantly go and look up different buffers in shared buffers. And this is happening for one kind of reason, and it's down to that kind of loss of correlation. It's because we're using so Postgres's indexes doesn't have visibility information in it, that a row is within or outside of this particular transaction you're currently in. So to be able to check the visibility, we either have to go and look up that buffer in the heap and check the xmin, xmax on that particular record, or we have optimizations called the free space map, the visibility map. So we can actually go and look up in a bitmap that page is entirely visible to all transactions. Now, that optimization breaks down when you lose that correlation between how the index is structured and how the data is effectively structured, and that kind of randomness. And we can see exactly the same problem, more importantly, if we use randomly allocated 64-bit integers. So, conclusive evidence that this is not a problem with UUIDs. Okay, so I've kind of explained all the bad side. Now, the other part of the debate is, well, why on earth do you want to use them? And I think there's quite a lot of reasons. So, I tend to do quite a lot of web development stuff. And so many web applications, I mean, including our own conference management system, exposes sequentially allocated IDs. So if you want to go and look up speaker photos, you can just increment the ID on the URL and it will keep going, right? Now, that in itself isn't inherently a security problem. However, guessable IDs does kind of lower the barrier to a lot of things. And one thing that is good about UUIDs is, whilst it's not perfect security and it's more security through obscurity, it is a hell of a lot harder to guess a randomly allocated 128-bit number than it is to guess a sequentially allocated integer. So this is one of the reasons I quite like using them, because it gives you a level of inbuilt security in your app with absolutely zero effort and cost, where if you kind of want to follow some of the OWASP guidelines of how to do it all properly, it's actually very convoluted, and reality why nobody does it. Now, the other thing, and this is where we'll start getting into more of the fun dimension, is 228 is quite a large number. So we can actually use them to do fun stuff. But before that, the other problem I dislike with database sequences is that they are database generated. So you have to go and ask the database to give you an ID, either by inserting the data and then returning an ID, or by just requesting it directly from the sequence. So you've always got a round trip if you're inserting multiple records and they're all correlated. So for example, say you're inserting a subscription with some transactions against it. You've got to insert the record, get the ID back, and then do another set of inserts, which require you either writing some very complicated queries or stored procedures, or having an extra network round trip. Now, the thing I quite like about UUIDs is I can generate all those UUIDs in the application. It's, by nature of them, they are mostly guaranteed to be universally unique. And I can generate those IDs on all the nodes in my cluster. I don't have to go and request it from certain things. I don't have to worry about stuff being in sync, etc. And I can do it all before I go and insert data. So it's actually really useful in a whole bunch of different scenarios and applications than having to have all your IDs issued by the database. And that other side of them being universally unique then becomes quite useful if you ever end up with distributed kind of geographically split systems. Actually, the fact that those IDs are very unlikely to collide makes it very easy if you want to then either move data around or join data up into, say, an analytics system. So it kind of simplifies some of those kind of sharding and migration strategies. But the really fun thing I like doing is using those 128 bits to encode information into them. So the way I see it is I have 16 bytes to play with however I like, because I don't like following rules. So all of my applications pretty much encode information such as, based on different projects, tenant information in multi-tenanted systems, potentially like cluster information in sharded systems, some form of partitioning information potentially. And sometimes as well, it's useful to know that this particular ID is this object, that particular ID is that object, right? You know, it's nice to know that this is the ID for an orange and this is the ID for an apple occasionally. And so if we take a very simple example here, so we've got this nice indecipherable ID at the top, and then all we need to do is bitwise OR it, right? So we're just going to OR all the bits, and now we've made something where I've got a tenant identifier at the top, I have an object identifier with inside that tenant, and now I have the ID that I use everywhere that gives me those 2 bits of information really easily. So in this particular example, right, we are still allocating this ID roughly randomly. But the tenant ID is a lot more stable. So the kind of the MSB is actually changing less frequently. So even just doing this solves half of the B tree problems. But we can go even smarter. So this was an application I was working on recently where we actually encoded into the IDs. So these were the IDs that we sent to third parties and everything that correlated to a specific like insurance claim. And we encoded information, and the first bit was effectively the kind of what I called the chunk, which was a tenant and a quarter of a year. So we had space for 400 quarters roughly. And we actually then inside that had a time offset where we could actually go to 5-minute precision. So we could know the 5-minute slot within that quarter of a year that ID was generated. We then had information about what particular type of object this was. And for situations where we had like child objects, what particular sequence it was. So we can actually just from the ID know that this is an insurance claim and it's the second claim against a policy. And then the last part is all just a completely random 64-bit ID that is kind of there for stopping stuff colliding and kind of security. So this is the fun stuff I like doing. Now, the interesting question really is, can we get the best of both worlds, right? So can I have all my fun with my IDs and not suffer all the consequences of stuff being randomly allocated and all the index downsides? So there is a standard that's finally got standardized, and I believe Postgres 18 has support for it. So UUID v7, which is effectively just time prefixed random IDs. So if we go back to that very first slide, and I've colored it in gray here, you'll notice that the version number is now 7. And there is some variant information that is then specific to version 7, but we won't go into that. But effectively, the top 48 bits are a timestamp, and the rest is completely random. And just that one change is enough to solve all of the problems with indexes, because the top MSB is slowly changing and now has time locality in it. But that's too simple, right? I don't want to do that. So let's come up with my own scheme. So I came up with my own scheme called, I've decided to dub fluid flexible UUIDs. And so part of the v7 spec is also introducing a new version 8, which is basically describing version 8 as custom. You can do what the hell you like. So I like those kind of rules. So I've kind of got a few different versions so that you can have 4 variants, right? So I've got 4 different variants of my kind of custom scheme. But following the kind of same basic principle that the top MSB is time. So we have a timestamp there, so we keep some form of linear order, and we then kind of play nicely with our indexes. I then, on a multi-tenanted version, have tenant identifier in there. I then have some additional kind of information I can code about, say, what the object type is. And then we just randomly have the rest as completely random. So there's another version as well where it does come with more rotating blocks, because even sequential IDs aren't perfect for indexes. So we also have an option to effectively just keep rotating around in X number of months the kind of IDs. So let's take this example and then run the same query I was doing. And we can now see that, so in my particular instance here, where this is a UUID where it is time prefixed, randomly allocated. So we still got like 80 bits of random data in this ID. And rather than, we're hitting a few more buffers, but it is nowhere near the catastrophic problem of completely random. And the same in the multi kind of tenanted situation. We kind of have slightly less data in that particular case for the timestamp. So the number of buffers we hit does get worse. So there is a bit of like how much time information to encode into the ID does change how effectively Postgres's optimizations work. And therefore, kind of dictates actually how good or bad this particular approach does or doesn't work. So obviously in this instance here, with using the multi-tenanted version, we have that shorter time section. We do hit almost double the amount of buffers, but you've got to take your trade-offs, right? And it all depends on how many tenants you have, etc. as well. And then say different schemes kind of get the different kind of processes. So by using a bit more time information, we kind of then actually solve the problem slightly better than having less time. So it's a bit of a trade-off of how much ID space you might want for having tenant information versus how much you might want for time information. But you've got 128 bits to play with. What more do you want? And then I thought, let's talk about the kind of actually insert performance. Actually generating these IDs and inserting them, are they actually much slower? Turns out, not really. At the end of the day, the bulk of your kind of insert cost is inserting the data of your row, not the ID. So in this particular instance, so this is a benchmark from a Java app inserting 10 million records, 500 bytes of data per record. Obviously, our sequential big int is the fastest, but actually all of our UUID schemes are not depreciably different from just a random 64-bit integer. And in fact, some of our schemes are ever slightly faster than using Postgres built, using a pure random. But at the end of the day, actually insert performance isn't that much different than the kind of best case anyway. So in other words, don't worry about it. Right, now we can get on to the proper fun part. And it wouldn't be one of my talks without some good old procedural SQL. So this is a bit of demonstrating the fun things we can do with Postgres and the fun things we can do with these IDs. So can we generate this random ID scheme in pure SQL using Postgres? And the answer is yes, we can. And it might look horrific because all it's doing is really a lot of string chopping and hex encoding, but it works quite well. So effectively, we cheat slightly by just using Postgres's gen random UUID to get us the base random, and then we lop off everything we don't want, and then just concatenate together the data we do want, encoding into hex, and then cast it to a UUID. I did do this talk at PGDay, and a few people said, "Oh, have you tried benchmarking it with, say, using the bits versus that?" And the answer is no. I will come on in a bit to actually, I did write a C extension. Surprise, it's not actually that much quicker than just doing this horrific thing. But of course, I work with a team of developers, and I shall say that not all of them had the same level of appreciation for this fun that I did. So we need to give some rules, right? So how can we actually decode and extract this information so that, more importantly, I can then go on and add a check constraint? So first off, actually, how do we extract the information? So I'm still a bit irritated. Postgres doesn't have a parse hex function. I really should try and raise a patch, maybe. But the trick here is we have to just use PGSQL this time around rather than pure SQL, and use the kind of select X trick. But the nice thing we did was, because we laid stuff out so it all aligned to nibble boundaries, all we have to do is use right and left to take out the particular hex digits we want, and then convert it from hex to an integer. Again, actually not that complicated, really. So now we've got a function that can check the version of a UUID. And now I can do this, so I can add a check constraint to the table that says, you're only allowed to insert UUIDs in this table that meet my own custom scheme, so that if you try to insert a random UUID, you get an error message. And now I'm happy, my developers less so, but hey-ho, they'll learn slowly. And then we can go, slightly further and actually say, well, let's extract the variant information as well. So all we just have to do is pick out a different nibble. And then we can update add check as well to say that, I only want IDs of this particular scheme in there. So because I've got different variants, some that specify it's a multi-tenanted ID, I can now enforce at a table level that my primary key is guaranteed to have tenant information in there. And now we can kind of play around with time and have some fun with that. So the first half of the first kind of prefix of all our IDs is actually a timestamp. So again, we can write a function that takes that ID, extracts the timestamp, and now we have a way to get the time out of an ID. But it's important to realize that because the time is in the MSB, so the most significant bytes, we can actually, they are in order. So a lower timestamp is a lower UUID, and a higher timestamp is a higher UUID. So we can actually do something like this, where I don't necessarily need a created column on my table to know when a row was created. I actually have a level of precision in the ID itself to know when that particular row was created. So just doing this mad thing here that's very hard to read, that's kind of searching for 1 month in January this year. Might not look like it. But now we know we can do that. And that will work with UUID v7s. Now we can do that. It means we can actually partition our tables by primary key based on time just using a UUID. I think that's pretty cool. And I believe some people are doing that using UUID v7. But to make it a bit more readable, I created a function that you give it a timestamp and it generates the ID for it. And now you can just write something like this. So create table partition of 4 values from this time to that time. And you know that that table will always have rows that were generated in that, between those particular times, just using the UUID primary key. Now we can go a bit further as well. So because I'm not just using time-based, I also have tenant information in there. So the really obvious use for this is actually just inside my application. So let's take a simple example. I have 2 database clusters, and I put 50% of tenants on one, 50% of tenants on the other. Then in my application code, whenever I'm looking up, load this particular subscription, I've already got the primary key, but I can pull the tenant information out of that. I can then look at what database it's in, connect to that database. So pretty kind of common tenant kind of sharding strategy. The advantage here is I don't need to have a magic tenant ID. It's already all in my single ID. But we can go a bit further. We can do that in Postgres, right? So we can also extract the tenant information in Postgres, which then lets us do stuff like this. So, filter, find me all rows in a table where the tenant ID equals a particular tenant. And we could also say, well, let's make that slightly quicker so we can use Postgres's expression index support to actually just create an index on the result of that particular function. So we can actually do that and still have good performance. Now, what I thought would be really interesting is, well, can we partition by tenant? And the answer is kind of. So we can actually do this. So we can do a list partition by the result of that function. And then we can create partitions with that, and especially have a default partition because we're doing list partitioning, and therefore create partition for our tenant. And that does all work. The only problem is Postgres isn't smart enough to know it should call the function to then work out the constraint exclusion. So it will just scan every single partition you've got. So we can do like 50% of it. We just can't do it fully yet. Maybe that will change in future versions of Postgres. And then if you thought this rabbit hole couldn't go any deeper, well, so I alluded to this a bit earlier. I decided to write a C extension. So this does exactly the same as my horrific string manipulation to build an ID, or in this case, sorry, to extract time. And I've got another one that will do it to extract the tenant information. And we can obviously, compile that code, register the functions, and we'll see that actually it's nowhere near as fast as you think. That actually using C to generate the functions is only 25% faster than my horrific string manipulation, which really quite surprised me. But yes. True, I did not select it, just select count. Oh yeah, sorry. The question was, did I test this just on select count, or basically just generate series? Maybe would be another way to do it. I might have done, I can't remember, but yeah, I probably did also test the insert performance. So yes, that's probably a good point, and maybe I should try that again. But I guess my point would be, I'm trying to keep the benchmark consistent with what I was doing all along. And actually, in most cases, I am generating the UIDs in my application code, so I don't really use this very often. But what was interesting is that the extra effort to write a C extension and install it, on those few times I do actually generate a UUID in the database, wasn't really a problem. I guess to explain things a bit better. And with that, we said it would be slightly shorter. So any questions? Am I a complete lunatic? There's one.
Okay, one question here first.
You started off with saying that you can use a UUID created in the app and then have no back and forth to the database.
Yep.
So, and it has no collision.
Theoretically.
Well, theoretically, no collision. So what happens if you use your fluid IDs or UUIDs v7? Then the chance of collisions, they are going up. So what's your thought about that?
So yeah, the maths is all basically the same maths as the common birthday problem. And obviously, the less space you have for random, the more chance of a collision. But in those time particular UIDs, right, you've got to now you've got less size to find a collision, but that collision has to happen within like a 5-minute time span. So I personally, I don't run like huge, web scale, etc. So in all of my normal business projects, I have never actually hit a collision. If you do hit a collision, your primary key is going to catch it anyway, so it's not a problem. Unless you're maybe got two completely geographically separate stuff where you've not got like one index. But yes, there's always a chance of a collision. It's just extremely unlikely, and I've never seen it happen. Any other questions?
Yes, another question there. Mikkel.
Give you some exercise, Boris.
Yes, since you are on the topic from IDs, that is, you have also a smaller one. This one is the UUID. You have also the Snowflake ID, and I thought, did you, how it's called, investigated on this topic also?
No,
or is it too small space to comfort you?
For the stuff that I've been doing, I kind of prefer the extra size. So the Snowflake ID is basically a time-bounded but randomly generated 64-bit number. And yes, it would still satisfy all the conditions, but you wouldn't have the problems that you get with pure random data. So it is better than just a randomly allocated 64-bit number. For my particular use cases, I've always wanted the extra space and the ability to have more information in there. And the other problem is when you do start bit masking stuff, the space shrinks quite quickly, quicker than you think. And sometimes, I do want more than 32 bits for a tenant ID, for example.
Yeah. And the second one is the 2 8s. Those are free. Why are you still sticking on it then?
What, sorry?
On the UID, you have the two fixed positions. The,
right.
The
yes.
version and
yes.
the variant.
Yes.
And my question was, why do you in Postgres you can also leave it free as an extra space?
Yes. I would argue you probably always want to use the version because it is actually useful information. The variant, maybe not. So yeah, if you do use that extra nibble for extra random data, then you kind of lose the ability to say that this is a random one or not. So I would say, for me, it's still useful to know that, which is why I kind of don't want to use that extra space. The variant, yes and no, sometimes you can do that. The rules around it get more complicated because most of the specs don't say you can use all the 16 values, so you can't use the full 4 bits. Which is why you only get really 4 variants you can use in a lot of the standards. But it all depends on compatibility as well, right? If you've got to send this ID to another system that might be parsing it following a more standard, following a standard compliant parser, then I would argue you're better off trying to follow the standard than just squeeze a bit more data in.
Thanks.
Okay, so this has been obviously a very good choice for a talk, to talk about UID based on the questions that we have got here. Chris is also going to be here the rest of the day, so if you have more questions, please reach out to him. I have some questions about distributed UUID, which is, but I'm not going to do it now because I want you to have a look at the zoo. We have a little bit of time now. You can roam wherever you want to go. The food is going to start here at 12:30. If you come a little bit later, it doesn't matter because then we avoid the rush of everybody trying to fight for food. Yeah, we have evolved a little bit from that period of time. So you have time from 12:30 and 1:30 to get your lunch. Before that, you can go and take a picture of yourself with the elephants, and you can get a chance of winning one of those beautiful electric elephants made and donated by Chris. What he hasn't done yet is key rings. So that's why we are going to give him a key ring and thank him for his especially nice talk. So thank you very much, Chris. Enjoy the zoo, enjoy the lunch, and we see each other here at 1:30. If you come a little bit earlier, even better, because we can start at 1:30.
PGDay here, Rotterdam, yeah. 20 to 5, low end is live. PGDay here, Rotterdam, yeah. 20 to 5, low end is live. PGDay here, PGDay here, PGDay here, PGDay, 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 PGDay here, Rotterdam, yeah. 20 to 5, low end is live.
Welcome to PGDay Lowlands, Rotterdam 2025.
PGDay, PGDay here, Rotterdam, yeah. 20 to 5.
Chuk.
No problem. Number one.
PGDay, PGDay here, Rotterdam, yeah, 20 to 5, low end is line.
Welcome to PGDay Lowlands, Rotterdam 2025.
PGDay here, Rotterdam, yeah, 20 to 5, low end is line. PGDay here, Rotterdam, yeah, 20 to 5, low end is line. PGDay here, PGDay here, PGDay here, PGDay, 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 PGDay here, Rotterdam, yeah, 20 to 5, low end is line.
Welcome to PGDay Lowlands, Rotterdam 2025.
PGDay,
Test, test. Okay, welcome back from lunch. I know you were all waiting for this moment of the day, and we will now have our lightning talks. First speaker is... Oh, wait, I need to explain the rules. I forgot. So we have 5 minutes, and when we are at 4:50, I will stand. I will be sitting here. I will stand, and when we are at 4:55, I will start clapping my fingers. Oh, sorry. And then you can also start clapping. And then when it's 5 minutes, you are out. You need to go. Okay, that's it. Now we do have our first speaker, Shivadeep. I hope I didn't butcher the name. So welcome on stage. You have the clicker, right? Cool. Let me start the timer.
Hi, good afternoon. This works, right? Yes, I'm Shiva. I work for ING, and I'm Oracle Database Administrator. Yes, still Oracle. How many of you work with Oracle still? Oh, good to see, good to see. Today, I would like to talk how far did Oracle come with respect to database on Kubernetes. Don't try to read it all. Just be with me. Before Kubernetes, does Oracle even run on containers? Anyone run Oracle on containers? Not yet. I see some nods saying no, but officially, starting 2019, Oracle started publishing official container images, and I read, and I'm not working more with Postgres. Postgres started around 2015, so a little late. And then I started looking, is there an official Oracle operator from Oracle? So there is one. It's called Oracle Database Operator, in short, Ora Operator. And this is to manage Oracle databases on Kubernetes, and it is free, open source, something which you rarely see free from Oracle. Container images, there is a lightweight version of Oracle database, especially for containers. And of course, you don't get all the features you need in that light version. And Oracle 23 AI is again free. Coming to Kubernetes operator, we all know there are multiple, and I learned CNPG is one of the most adopted and most famous in Postgres community, and I try to make little small comparison, and both started around the same time, 2022. Oracle as or operator was also around 2022, and one good thing is with Aura Operator is it is supported and tested with all cloud providers, all Kubernetes flavors, Azure, AWS, Google Cloud Engine, and of course Oracle Cloud Kubernetes Engine. And but with contributions in GitHub, I mean stars in GitHub, Aura Operator got only 164 stars, but you see CNPG 6,700. Maybe this number might have increased by now. Remote management, this is the word which I gave. This is not something officially official word from Oracle. With this Aura Operator, you can not only manage, administrate databases running in the Kubernetes cluster, but you could also manage databases running remotely, for example, on-premise. And if you have this operator in OCI, Oracle Kubernetes Engine, you could manage databases running in Azure or on-premise or Google. This is one particular feature which I really liked. And when I submitted the CFP or beginning of this year, it wasn't recommended to run. I mean, in the documentation, it wasn't recommended to run or operator on for production. But now it is released for production, so that's why it's not really readable. So that not production ready is striked off, not is striked off. And if you know, in Oracle, there are multiple flavors of running database like multi-tenancy, tenancy. So there is container database and pluggable database, which is supported, and traditional non-multi-tenancy is also supported with Aura Operator. But CNPG Operator, it might run on another other Kubernetes flavors, other cloud providers, but I think it is only tested when there's a new release, only on vanilla version, I think. And I learned, and I have also seen companies running CNPG Operator on production. So it is well adopted in the market, as far as I know, the CNPG Operator. So with these figures, in terms of community adoption and actual companies adopting the operator, Oracle is lagging behind, but I think they are, in terms of features, this operator already could do quite some stuff with Oracle DB management. So they are slowly following. With that saying, I don't say which operator is winning or which operator is losing. That's all I would like to. I wanted to introduce. These are my slides, and this is me. Feel free to talk to me regarding data on Kubernetes.
Thank you so much. We are out of time. Before you leave the stage, oh my God, I will try. This is a small token of appreciation of your presence here today.
Thank you. This is small token.
Yeah, thank you so much. Okay, what do you need? It's here. I have it. Anyways. Oh, I know what you mean. Yes. We have our next speaker. It's Cornelia. So please come to the stage.
Is it okay to start? Okay. Now. Okay, back to Postgres. I will show you or introduce you now to the idea of the PostgreSQL village. Sounds interesting. Let me explain this a bit to you. I recently heard a nice phrase saying that if you want to go fast, you're okay to go alone, right? But if you want to go far, you have to go together, right? I will explain this in a bit, but let me just quickly introduce myself a bit. So my name is Cornelia Bircic. I'm heading up the marketing team at Cybertech. I'm a founding member of the Open Alliance. Jan introduced us to this yesterday at the meetup, if you remember, and we're there. But first of all, I'm a member of this community. So although I'm not a technician and into marketing, I'm a member of this community, right? So back to this village idea. What is a village? So if you think about a village, diversity would come into your mind, actually into my mind, because I had the idea of that. So you have different people of different interests with different origins, and you could even come from different families, but you live in the same village, right? So you have something in common. And oops. Same with Postgres as well. So Postgres is a project we're all working for. I mean, not all Oracle people are also here as well, but there's also something in common. So although we are coming from different interests or groups of interests like marketing, sales, technicians as well, we're working for Postgres, right? So the idea of a village is to get people together, to work for the same good or to have the same good in common, right? If you think about how to solve things for a project. So how can you actually connect in a village? And I would say with mingling together. You can do this at Postgres, of course, on conferences like PGDay Lowlands, PGDay Austria, PGConf Europe, you name it, right? But there's also the social channel on Telegram and more, and this is how I recommend you to get started with the community. There are a lot of groups there, like chess groups, there are conference organizers groups, technical groups, marketing groups, you name it, right? You can even open your own chats there in order to get connected with each other. But why should you do that? So I believe very much into connections, personal connections and touch points. So if you find personal touch points with other people, then you're more likely to get into conversations about the professional things, right? And we together can do great stuff within Postgres, no matter in which area. You can do that in marketing, in sales, or if you contribute in terms of committing to the project, to Postgres itself, right? Coming back to the Postgres village, I believe that we are all working for the same, no matter where you come from. Postgres is a village where we can all contribute to and make this project the best project it could ever be. So back to the phrase I started with, we shouldn't go fast, we should go together. Please connect at this conference, get together and make Postgres better. Thank you.
Thank you so much. We finished a bit early, but still, thank you so much for coming today. And we can now go to the next speaker. Oh, the clicker, yes. Aha, now I managed. So now we have Mayuresh for the next talk, correct?
Yeah.
So, clicker.
Thank you. My name is Mayur. I have been working as a DBA performance tuning engineer for the last 15 years. So this is about Postgres compatibility index. So Jimmy earlier talked in the morning about a requirement or a need to have something that defines what Postgres is. This is an open source project I started last year. It is kind of a measure of how far away from Postgres your shiny new Postgres compatible product is. And a little bit about origin story. I started working on this when Amazon launched DSQL, and there were viral discussions on Hacker News or social media that they claimed it's Postgres compatible, yet it had no views, no notify, no subtransaction, no JSONB, and a lot of other things were missing, no extension, of course. And then this is, we were discussing, this is Gunnar from Debezium frame, and Tudor, he works for Zeta, I think Zeta CTO. And we were discussing about the need to have something that describes how far away your shiny new product is from Postgres that you're claiming it to be compatible. So, I mean, there is a reason. This is the reason. So I don't blame them because it's natural, because Postgres has 30 years of network effect, and a new startup or new Postgres company or new Postgres derivative company would obviously try to cash in on that network effect. But then what's stopping from Larry Ellison or Oracle saying they are the world's most advanced enterprise Postgres compatible database? Nothing till now. So, this is about the Postgres compatibility index, and it runs various tests, and each feature is scored, and then results are sorted accordingly. Whatever. Yeah. So this is the website. It is functioning right now. You can scan this QR code, and it should lead to you this website. It looks better on desktop than mobile. And as you can see, there are this is a comparison of different Postgres derivatives and some popular, commonly known as Postgres compatible Postgres databases. And then below you could see all the feature, which feature is missing. In website, you can play with it. You can use drop downs or filter by a certain derivative or certain product. And basically, this is how it looks like when you are scoring it behind, not the website. And if you are if you want to add your Postgres compatible product, then you can just send PR here. It's open source, so it's free. So, or if you want to contribute, if you want to suggest better tests, like add more tests or improve it further, then you can also contribute here. So I will keep this on for next 3 minutes. No. And this is my database comedy blog that explains this Postgres compatibility index in slightly further details. And thank you.
Thank you so much. Can you hear me? Yes, cool. Thank you. So we will have the final lightning talk of today, and it will be Dirk. Please come. Oh, you need this.
You can also click for me. I have very, very little slides, so it should be fine. Like Postgres is a village, right? And I'm one of the chess players. That's the only thing you need to remember. If I'm not organizing a conference, I'm here carrying my chessboard and a clock, and I love playing chess. But that's not what I'm talking about today. What I learned in life is the loudest voices always win. It starts at primary school, where the loudest kids, they get attention, they get what they want. And if you're a bit silent and a geek like me, no one looks at you. And at the university, it continues, like you do all the hard work on a project, and then someone else doesn't really contribute to it, but then they present the project to the professor, and the professor loves them and gives them high grades. And it feels so unfair. And what I learned in life is I'm an introvert. I don't like to be in the spotlight. I don't like crowds. So yeah, what am I doing here? And to make things worse, I think it's very natural to be so scared of public speaking. Because the oldest part of my brain, the reptile part of my brain, the one controlling the freeze, fight, flight reaction, is telling me, dude, you're standing on a stage. There are 100 potential enemies on the other side. If they decide to attack me, I don't stand a chance. So against all the odds, why do I travel Europe, the world, to do public speaking? And I think the only good reason to do public speaking is because you have a message to share. You don't do it because of ego. I don't want you to look at me and think I'm cool. I think when I'm standing here, I have a message to share, and it's important to share this. I'm part of this great community and I want to do something back. And the best I can do is share my knowledge with all of you. So that's why I'm here. And it's scary because my brain says, you might attack me and I need to run. But what I learned over time is you are here to learn something from me. None of you are here to hear me saying, you need to buy more stuff from me. You need to spend more money on me. No, you are all here, I think, to learn. And you are all working in IT. So I'm wondering, out of you, because in life in general in the population, between 25 and 40% are introverts. But in IT, there are way more. So who considers themselves to be an introvert? Yeah, that's way more than average. So I want to encourage you all, stand up and share your message, because everyone has something to share. And realize people are here to learn from you. The spotlight is not on me. I'm not in the spotlight. It's not about how I behave, how I have my arms, whether I'm taking lots of space or not, right? It's about what I want to share. And today I want to share, like, be a lighthouse like this one. What you can do is you can guide people from where they are to where you think they can be. And if we all introverts working with Postgres share more of what we know with this great community, we are all going to grow. And not only the community will grow, but you will grow with it. Because if you learn how to build your arguments, how to build your story, how to have influence, you don't need to have the loudest voice in the room. The better I get at public speaking, the more people listen to me in live as well. If I'm in a meeting, I no longer need to raise my voice. When I speak, people listen. And I want all of you to experience the same. Share your message and make sure people hear you. It's good for you, it's good for everyone. Thank you. I wanted to claim the stage already.
Yes. Where is the clicker?
I put it.
I was missing something. Aha. Okay, cool. Thank you so much for your inspiring talk.
Thank
And
you.
that's all for the lightning talks. And we will have other talks next, but you will do the work. So.
Yeah, I have to do the work. I have to click. Oh man, I was so focused on my talk. I need to reset for 1 second. All right. So what happens if I click on nothing? Oh, Johannes, I think you have your own laptop, right? Yes, that makes a lot of sense. All right. So next talk is from Johannes. And when I was reading the title, I was completely wrong about what the talk was about. And then I was reading the abstract again, and I was thinking, like, hey, maybe this talk is about a friend of my wife, because he's doing kind of the work he's describing in the abstract. He's working with trees. But he's working in Germany. My friend works in the north of this country, so they're obviously not the same. But yeah, I'd love to hear your introduction to Postgres. Please take it away.
Well, I just wanted to share some thoughts on my way to Postgres, which was coming to me suddenly. I had my neighbor coming to ring on my door, and he just said, well, you work with computers, can you help me with a project? And so I asked him what it is about, and he told me, well, he works with trees. He visits about 4,000 trees every year, and he examines them regarding their health. Sorry.
No, you need to switch it here first, and then I'm going to switch it back then.
Okay. Yeah. normally I have started it like this. Normally it works like this. So he goes to about 4,000 trees every year and checks about 100 attributes on each tree. And somehow this data ends up in a database. So his idea is, in Germany, everybody who works like him has such a database of some 1,000 trees. So why don't we make one large database with all of those trees? And the idea behind it is then to put that data on a map in the internet so that everybody can look in his area how healthy which type of tree is in his area. So for example, if in your area oak trees are dying, it might be a better idea to plant some different trees and not oak trees again, because they might be dead next year again. So that's the basic idea behind it. And his idea, of course, it should happen soon. It should work within 6 weeks, or 6 days would be better. And all of that with me doing it alone in my spare time, so not really happening. I told him I never designed a database before. I never created even a website before. I never wondered how to display geolocated data on a map, and didn't ask myself how to add any layers to it. So it would take longer. But since I've always been interested in ecological things, and since my kids are now both beyond 20, I thought I have a bit more time so I could give it a try. And then I started thinking about what could I use for it. And since trees don't move too much, I looked for a database system that can handle geolocated data. And that is how I found Postgres, and through that then Postgres. So that's what I decided to use. And then the question was, how do I get the data into my database? And the idea was, I need to import CSV files, because he has his database, can export them. So how hard can it be? Well, it starts with, if I want to import it, he has to export it, but he has no clue how to do that. So he needs some support for that. He managed to do that, but something's wrong. There's so many semicolons. So then I finally had the CSV file, and maybe it would be easy to import it, but it was not. So let's look at some of the issues. You can see these are just the names of the trees. And it starts with that already, because there's not a unique way of identifying trees. And we had to sit together for quite some time to get a list of names that we then want to use. But there are also issues with that, like you can see here species. Some nomenclations call it species, some call it spec, some call it spec dot, and the database has to know all of that is the same. Then I found a tree called Brücke, bridge in English. I said, what's that for a tree? And he says, it's not a tree, but it's a bridge that I need to find so that I can then find the tree behind it. So every tree that is called Brücke cannot be imported, and more things like that. Then he has comments in his data, and the comments sometimes include a whole address or an email address, phone number, whatever. So data that I cannot include for data protection reasons. So all of these need to be filtered out. Then there are at least 5 different systems that are used by people who work like him. And I got other CSV files where there was not even geolocated data, so I cannot import that at all. They first need to create a new way to export their data. So this is an example of the start of a CSV file, and I will show how I then went about, for example, the Deckungsart, which is one type to describe how the area around the tree is. So I create a search string where I say, search for the Deckungsart, and then I add the Deckungsart that I found in the CSV file. Then I check if that Deckungsart is already in my table Deckungsart. And if not, I try to insert it. And if it worked, everything's fine. If not, I say I could not insert it, so I need to debug later why it didn't work with this tree. Then I get my table with all the Deckungsarten that are in the table, and can then use them just through their ID and not have to put all the text, which can sometimes be very long, into my table where I store the data. Here are some two other examples, how the tree top is formed, or which type of grouping they have. So I come up with a table like this, where all the indices of my various tables are used. And here is also the geometry data. But there are so many projections. How should I import those data? Which ones should I use? So I looked and found, for example, that these can make a huge difference. If you look at Europe with a normal projection and with an Australian one, it doesn't really match. So choosing the right one seems to be important. And I settled for 4326, which seems to be the proper one for my area. So many people don't like pgadmin, but to view the geometry viewer, it is very useful. And I check where my trees are in Germany, and there's none, but here are some. So what happened? Let's look closer, even closer, and then switch Y and X, and we find them. So obviously they export latitude for longitude and longitude for latitude, which then creates the next problem because I told them so, and then they changed it. So now I have always to import data from before and data from afterwards to have the correct location. And as you can see with this tree here, the projection doesn't really seem to fit completely, so I'm still looking for a better way to adjust them so that the tree doesn't grow on the street. So now we have the data imported, and how can I display it correctly on a map, not just with the GeoViewer of PGAdmin. So I added GeoServer, and it looks something like this, where I can give the trees different styles depending on their health status. And if you click on any of the trees, you can get more information on that tree. Like here are some examples of free trees. And if you want historic data of one tree, you can also go back and see which data this tree had before, but in general, we only show the current data. So then the idea was we also want to know more about where the tree grows. So what do we add there? We add open layers so that we can add additional layers to it. Here are some examples of some layers that can be helpful, like weather, wind or precipitation, or how wet the soil is, how the temperatures are changing. And this gets put underneath the trees so that people can check whatever they want. Then the next question is, I want to be able to create any combination of those 100 attributes that I want. And I said, well, basically we could do that, but at least we should keep the geolocation in it so that we have less traffic and can narrow it down easier, because if you have any possible combination of 100 attributes, it is not easy to build indexes that then work for every case that you have. The next thing was to keep all the data forever, which, as I said, we solved by keeping the current set in the database and moving each replaced data into a history table that can then be found through the tree itself, but not directly on the map. Then queries should be even faster, so more indexes created, the database partitioned, and I also am starting to create new tables where I have a table just for one specific attribute, like the tree has sunburn. And then I add in this table all the trees that have sunburn so that I can very quickly find all of them, because not many of the trees in the database have this specific topic, but it's often part of the queries. Then another idea was we should store images of the trees, but then we decided we won't store them directly in the database, but in a file system, and then store the location in the file system in the database to keep the database smaller. So that's it basically from me. If you have any questions, feel free.
Thank you very much. Amazing how much good decisions you can already make for such a small project. Well done. Pretty cool. So who can I help with questions?
I'm curious about size. How big is your database and how rapidly is it growing? So
Well,
rows or gigabytes?
It's still in the beginning phase, but according to my neighbor, he estimates it will be for Germany about 2 billion trees. In Germany, it is recommended that every tree that grows next to a street or on a parking lot or wherever is monitored, so that people who check the trees can assure that no branch will fall off and kill someone or something like that. Therefore, there are about 2 billion trees that are monitored at least once a year. 2 billion.
Just curious, why is this not a government initiative? Because in Holland there are cities that monitor their trees. So why is it? It sounds like it's done by individuals and not by government.
Each community employs someone who does it for this community. Therefore, each community has the data of those some 1,000 trees that someone checks there. And from that came the idea to combine all of those into one database. So basically the data is already there, but it's separated in many databases all across Germany.
Okay, do we have more questions?
Do you have many free text fields, and have you considered using full text indexes to search them?
There are many, but the content of them is not part of the query. So if you look for a tree, there are about 90 attributes you can choose from, but the comments then come along with the tree data in total.
You started the presentation with the time you want to spend on this project, 6 weeks or 6 days. But how many years is it?
That's a good question. As I said, I'm still working on it, and I still don't have the final project that I could offer someone, because the idea basically is to create a prototype and then ask maybe the EU or anybody else who is interested in such an environmental project to fund it. But we are not at that stage yet, and I think once we get to that stage, the real work will only start. So it will be endless. Sure.
So you have your neighbor as one data provider. How many other data providers have you already been integrating? Is that a few? Is that a few hundred? Because you have 1,000 from your neighbor, and the estimate is a few billion.
Yes. At the moment, I have about 10, so roughly 50,000 trees, but I've also generated sets randomly so that I can test with larger numbers. But so far, we are still looking to get the prototype running so that we can then tell people, wouldn't you want to contribute your trees to the project as well?
All right, do we have one more question? Yes.
You said about the special tables with some kind of special attributes. Have you considered to use the index with where parameter? So where some attribute equals to whatever?
I haven't checked that in comparison to the tables, but I've had large improvement in query times when I used those special tables, but I can also give a try with that. I'm still learning Postgres, and everything that might help there is always welcome. So if you have ideas, feel free to contact me. Other people also suggested it might be a good model to help training AI that tries to detect trees from satellite images, because if you know 2 billion trees in Germany are exactly this tree, it's much easier for them to learn how to spot them from the air.
Thank you. Do we have more questions? Asking once, asking twice. All right. Thank you very much.
Thank you.
All right, Dirk, I think you're next.
Oh, you don't have it? I don't have them. I will search for it.
Thank you.
In the corner. That's found it.
Ah, yes.
Call him and
Let's search for it.
Well done. Thank you. Thanks
you.
a lot. And also one nice keychain for you. It's a cool project. I need something. First, do we need to wait to start, or can I introduce him? Because officially we have a 5-minute break, but you can introduce him. Looks like you're ready.
Looks like.
Yeah.
Am I on? Yes. Okay.
Yeah. I had a really nice discussion over lunch with some former colleagues of mine. They were asking me like, hey, there are so many extensions around in Postgres. Is it really easy to mess up your database with it? It's like, well, you have a good point. You can. So now I'm extra curious about your talk.
Okay, we'll see.
Have fun.
Okay, thanks. Hello. Also, yeah, thank you. Okay. Also, hello to the stream, wherever it is. This was a talk I did 3 years ago as a 45-minute talk. So they asked me to do it in 25. So I have to do it twice as fast. So I'm talking about extensions. My name is Dirk. I'm a solution architect with Ivan for almost 2 years now. I have on my plate about 18 years databases. I have a dark history in Oracle. You will recognize it a bit. I was a DBA, I was a trainer, I was a consultant, and I was a sales engineer at EDB, and now I'm a solution architect. Several roles, several names, but all was always about databases. Some private stuff if you need an icebreaker outside, but don't want to add, I don't have time. Important note, you know, I'm living right after the border to the, what is that, Highlands? I don't know, Germany. And I'm organizing the Postgres user group North Rhine-Westphalia, and we are switching cities every time. So could be that maybe there will be someone from the Netherlands also coming over the border. We did once in Aachen. So we had Belgian and Dutch people also there. So just keep in mind, next one is in Dortmund. Short disclaimer, you know, I'm talking about extensions, and I also will show how to write extensions for your own. But I'm not a developer, so bear with me. You know, it's just an example, just to give you an easy start for doing this. I'm just usually a desperate database guy, like most of you maybe. And yeah, that's it. The idea of extensions, I think everyone will know, it's having just the basic functionality in Postgres, and everything else we want to extend to keep the database kind of small and not so overloaded. And to make this, we have a standardized interface. And we want to make sure that creating extensions is open and easy, so that you don't have to care of much things to start with. So I will show you how easy it is later then. The motivation is actually, you know, I came a little bit from the Oracle world, and even when I see that extensions are a huge benefit, it sometimes is also one of the most pain points for a lot of customers and individuals out there, starting with Postgres, because they are missing stuff out of the box, and then you have to teach them, okay, that is on purpose. So Postgres wants to be slightly and easy, and then lightweight and easy, and then you add your functionalities like as you wish, right? And then you have only the functionality you really need. So that is, for me, it's a good thing, right? But you have to make this clear, right? So the real motivation is the argument. What I always bring up is I just did for fun install on the same machine several databases like MySQL, MariaDB, MS SQL Server. Yes, MS SQL Server on Linux. That is a thing. And also Postgres in several stages. Even Postgres 17, it was with some extensions, right? You see. And now guess, if you want to have this argument, right, what the missing numbers are. Any short guess? Yeah, okay, it's way more. And to be honest, I was fair. I just emptied the patch storage cache, you know, all the garbage lying around. So still, it is very fast. And these are, you know, this 6.1 gigabyte. That is an empty database. So it's just creating an instance with an empty database. So you have all together about 13 gigabytes without having any data in the database, any, you know, your workload data. Yeah, no, you can no argument about that. Oracle brings a lot of features, a lot of functionality in there, but still, that's way too much, right? But I talked to a product manager, and they are working on this. So that is 21.5. I think that's the last supported release. I have a 23 AI unofficially lying around somewhere. I will test it. Let's see. So what can you do with extensions? Everything, right? It's really fun. You can start with data types, like just packaging SQL scripts or everything what you want to do. You can create the extensions based on any language you want. You can create languages, programming language in an extension like PG SQL, and then you can use this language to create another extension. Think about that, right? So it's really weird. So everything is possible. It's really amazing. So extensions are really cool. But of course, there are things to discuss. Let's see if we can make it in this time. Where do we get all these extensions? So there are several sources, right? Everyone knows maybe the contrib package, which is maybe a good thing because that is a huge set of Postgres extensions maintained by the community, getting out every release. So if you want to have a healthy set of extensions, you can just install this and you are good to go. That is also supported by the community, so that's fine. There's also this Postgres extension network, which I was thinking about not to be alive anymore, but I got slapped by Floor that David Wheeler is doing a lot of work on this. So that is also still an existing thing. And of course, you can get it everywhere else. You can find it, you can Google it, and so on. The contrib, it's about, I don't know if it's the right number. It's, 3 years ago. In the past, it was about 49 extensions being in there. Could be more or less. It's around this, right? So you can just install it with the Postgres repository. Then again, this Postgres extension network, which is still alive, and they are maintaining at the moment about 430 extensions. They are listed there as a repository. You have also kind of a little command line client that you can install and update it if you want. So I didn't test, to be honest, the actual version of this, but it worked when I gave this talk back then 3 years ago. So at least, it's worth to have a look. And even when you just want to have some, let's say, established extensions, so we can have a look here. Yeah, and of course, installation over the usual repositories and so on. You can always self-compiling it if you get it from GitHub. For Windows users, it doesn't look so well. So extensions is one of the pain points if you have customers with Windows. I had this discussion. So customers were asking, we are using Postgres on Windows, why ever? And then they asked for this extension, and that was a problem. So I had no good answer to this, so shit happens. Cloud, that is also kind of a difficult story. Of course, when you're having infrastructure as a service and install Postgres for your own, you can do whatever you want. The same with all extensions. But most of the customers out there are using DBaaS. They are always depending on what the cloud vendors are offering, right? So like AWS or Google Cloud SQL, you have to check what kind of extensions are available. Also Ivan, I'm working for Ivan. We have also kind of 73 extensions available. Most of the hyperscalers and we have at least the contrib extensions being available and a little bit more. So we have to check. You can discuss, of course. You can try to ask AWS if you want to add an extension. Good luck. With Ivan, you can talk. So where are the extensions when you have it looking on your server? Like there are two important folders, share extension and lib. So here you can see there's the lib folder where the compiled versions of the extensions you will find. Here in this case, the PGDay statement, just an example. And then is the extension folder where you can find the control file and the related SQL script. So if you have a SQL-only extension without any code, any compiled stuff, then you only have to look at the share extension folder. That's it. So there you will find everything. I will show it a little bit later when on a live system, so you can see that I'm not talking garbage here. So you have always the components of extensions. They're starting everything with a control file. So you're creating a control file with some metadata about the extension. Can you use a version, the comment, and some parameters like if it's a trusted extension, if you want to make it possible to activate as a non-super user, things like that, right? You can look up in the documentation, whatever you can configure there. So that is essential that you have at least this control file. And then, you know, an easy example is having just a SQL script. So you don't need to write actual compiled code or something like this. You can start with a SQL script like this. That is basically just giving me some text back. In this case, what you see, what I need right now. And then you, of course, that is an easy example. You can start with this. But you can also write something, you know, compiling it. And then the Postgres community brought kind of an interface, kind of a package with the developer package. And I'm not even sure if you still need the Postgres developer package right now with this. But, you know, then you have this so-called this PGXS. It's kind of a building interface where you get everything what you need to create kind of a make file, write some C code, and just make it, compile it, and install it quite easily on your local Postgres instance. And the only thing what you need to make sure is that all paths are set correctly and pgconfig is somehow available in the right environment. I will show you later. That's way easy to start, right? So it's also good documented. There are a lot of parameters you can use in the make file, so it's not a problem to start. Even with me not being a daily developer, right? I learned C back then in my so many years ago in my study time, and Java. So it's I was able to make. So, and then of course you can start with an easy C file, right? You know, I'm not a developer. I'm just adapting this. I don't want to go into detail what everything of this means, but this is an easy example just to get, you know, the same like the SQL statement, just to get out some text like a hello world, right? So, and the SQL script stays, but just referring to the related C extension, then the C code and the compiled version. So that's it. At that point, I will show you this. If I think we're good in the time. I like to do demos. So you will see what I have here is kind of a Postgres instance. Yeah, it's 18. I'm testing, you know. And as you can see, I will just start in here. At the moment, I have in the extension folder of my installation folder just only the default ones, like PL, PG as well, right? And nothing more. Like, and what I have done is I prepared the just the examples, like the SQL example and the C example. So if you look here, SQL extension, that's basically what you have seen in the slides. So it's not nothing what I changed, it's just prepared, right? So what I can easily do, you know, at the moment, you can look with select star from PG available extensions. It's still only the PL PG as well. So now I'm just copying the two files, the control file and the SQL file, to the relevant folder. Zoop. And you can see that it's actually what I did, right? So, and it's immediately available, right? So now you see Dirk's extension, which is the SQL version, right? So now you can just activate or install the extension in this database where you're logged in. Create extension, Dirk's extension. So that's it. And then I should have, I'm lazy. Let me just find this. So now I get my, you know, what the text getting out, easy, right? You know, you can build everything you want. So you just have to use this framework or this pattern to start with. So it's an easy start for SQL only, right? And it's always good to need a beer, right? So again, now I have also done it with easy C, right? So, and thanks for Tomasz. He taught me this actually. That is really cool in Prague. So just having a quick start with C code, writing an extension with C code. So basically what you see here is also what you have seen in the slides, right? It's not like something different. It's exactly the same. It's just giving a string back, right? So now I have also created the make file here, also like in the slides. So with the usual stuff, just make sure that the PG config is available. So like this, if that will work, then you are fine, right? So just give all your information you need. So then I can just compile it. Bam. So now it's compiled. Then you now see all this compiled code, right? And you don't need to copy it right now because you can just use the framework and do make install, and you are good to go. Right now, when everything is working fine, you see also the C extension, right? Which is, of course, nothing really useful, but I can create the extension and also, where is it? No, still need to be with C, right? So that's basically the same, but as compiled version, ready to go. So that's basically it, right? So it's pretty easy to have a start and implement something yourself. I'm having no idea right now what I want to build, but I know how to, right? So now I have to find any cool feature, cool solution, or cool anything to continue working on this and creating an own extension, no matter if you want to do it with SQL or with C or with any language you want to use, right? It depends. The framework is basically optimized or generated for C code. So if you want to start with other languages, you have to take care about the whole build management and so for your own. But that's basically it. So that is implementation. So I was really proud of myself doing this, right? After 18 years writing C again, feeling like a hacker, right? No, just kidding. So, okay. That's basically what I have shown you just in the slides when the demo will fuck up. So you have seen this. You can also drop an extension, of course. Sometimes extension also need bring in some parameters with or without cluster restart. So that could you also have in mind. The classical one is pgstart statements. If you didn't install it per default and before you start with your production environment, then you have to change that and have to restart your cluster. A common mistake, right? You can even alter extensions, adding some views. There are some operations possible with extension as well. And updating is also kind of just update to and blah, blah, blah. Alter extension, update to, and then you can just update the version of your running extension. So if you need to update it all the time. So also I've shown this, I usually prefer the select from PG available extensions because it gives you way more information, but with the /dx, you get at least every extension which is installed, right? So it's more easy, more common if you want to have a fast shortcut on this. Okay, now about the challenges. So that was the main part of my talk back then, because, starting with extension, having extension available is pretty easy and it's a benefit. But of course, if you want to introduce extensions in a production environment, what is about the problems, or what is about how you explain a customer you can do this, but you need this extension and that extension, and the customer is thinking about why I started with Postgres. I need now new components, right? New software modules whatsoever, and that is a discussion I always have to do. And it has to go about the change management, and to have a lot of discussions. And what is about the restart of the database when you're adding extensions? That is actually a pain point. So how to solve that? Start immediately and find out what extension you need in the beginning when you start working with a customer or with a production environment, right? Then, of course, there's always this discussion. Customers want to have an all-in-one solution like Oracle. Then you have this large Oracle home, right? But the problem is that not everyone gets the point about having this tailored solution. They just want to have everything out of the box. That's not only a problem about extension, it's also a problem about the backup and recovery solutions and high availability solutions like Patroni. So that's the same discussion, right? Why is Postgres not ready to go immediately? Why do I have to add this and this? And then for Patroni, I need etcd, right? So the same discussion everywhere. So you have to convince customers or prospects in this quite early, right? That is, but you have to bring up the arguments like that. You're more flexible. It's really lightweight, and you have at the end you have a tailored solution. So you have the features you need, and not 100 features where you only need 10 of those, right? So that is a real big benefit, in my opinion. What also is important, like I mentioned before, not every extension is like surviving for always. So maybe if you find a cool extension which sounds great in the first place, and then someone stops working on this. So, so that's then a problem. You have to make sure that an extension is maintained properly, or even make sure that someone will take care of this later, or maybe you will do this when you're writing the code or want to take over. But that is the power of open source, but also kind of a problem. So, but you can easily find out. If you can look in the GitHub in the activities. But I'm always doing like, okay, when I see there's a lot of going on, and the commits and so on, then I know, okay, someone is or a lot of people are working on this, so that's fine, right? So you have to trust. So, but it's not always the case. But you can find out, and you can make sure, right? And you can always jump on this and develop your own. And what is about support? This section, it's good maintained. I want to bring it up in my production. What's about support? Who guarantees me that if there's a bug, who fixes, right? Of course, there are some vendors like the usual suspects out there having kind of troubleshooting or even code fix support for some extensions, which is nice. But you have to make sure that this is the case before you start with this. If you need an extension with a specific SLA, then you want to make sure that someone is taking care of this. Of course, there's a community support. You can always ask, right? But SLA is a thing that cannot be enough if you want to have at least in the next day having an answer on this. So my conclusion is, I think I'm good in time. Extensions are powerful. I think we are all on the same page on that, and often essential, right? There's always a never-ending story about having extensions per default. The classical PG stat statement discussion we have, right? The initial implementation of statements of extensions is simple. You can have an easy start, like I showed you basically in a few minutes, right? And you have many sources. And I'm looking forward to see more like this PG extension network, to have kind of a proper repository that also gives more trust into extensions for customers, like having a collection of extensions where you are thinking about, okay, these extensions are established, many people are using this and exchanging stuff and so on. That's good. And make sure that if you start a production environment, that you discuss the set of extensions in the first place, not later, because if you have a problem and you need PG stat statements or whatsoever, then it's always too late, right? And what I always do is kind of I have my own set, like my selection, what I always recommend, right, out of the contrib. Maybe, for instance, PG stat statements, there's a few others, what I always install per default, right? Even when I have the chance to select, then I do this. Yeah, that was, I hope, not too fast. You can ask some questions. If not, I'm outside. You can go to the Ivan booth or somewhere where you find me, probably somewhere where we have beer. And thank you very much, and shoot.
All right, I already see 2 questions.
Thank you for the talk. I have a question about the stability of the extension API on the Postgres side. Like, since it was introduced in Postgres 13, has it been somewhat stable, or is that like is there a lot of churn in that? Do you know?
What do you mean with stability in this case?
The methods that you use to interact with the database.
I had no issues so far, so can anyone jump on it? I don't have any experience with bad stability in extensions at all, right? So, it depends on the specific extension, of course. You can also write a shitty extension, right? If you write a hello world, you can do way more bad stuff, right? But that you can check for your own, right?
Yeah. Sorry, I mean, I'll talk to you offline.
Okay.
Thanks.
Thanks for the talk. My question about the Postgres observability. So while the extension framework is really good, but you're still limited by hooks and the predefined points where you can extend the Postgres. And when you try to develop something that help you to extend the observability of Postgres, you're really limited by the existing points. And even the PGStat statements that you mentioned, it's still outside of the core. Do you think this should be some movement that extend observability in Postgres, at least move PGStat statements to the core and something for like PGWet sampling to the core or something like that? Otherwise, because I mean, I observed a couple of installation of Postgres when the people just fly blind because I mean nobody told them to install in these extensions, and I mean, and if you move it to the core, you can achieve the goal with a way less of a overhead than the extensions give. Even PGStat statements have visible observable effect like 5% sometimes.
When it's up to me, I would say yes, but it's not up to me. There are other people maybe in this room you can discuss with this. And yeah, that is, you know, I get this question every time. So, you know, there's a huge discussion about a few parts having this also in core, but I don't get it. Why? Not everything, right? But PGStat statement is the one famous example. I don't almost know anyone who doesn't want this in the core, right? So at least this.
Okay, historical reasons, right?
Yeah, it's essential, right? That is what I mean with some extensions are basically essential and it should be in the core. At least being ready to get activated, right? That you don't have to restart the cluster after this. That is the biggest thing, I guess.
Okay, thank you.
Thank you for a great talk. Very quick question. What sort of monster spells make file with a lowercase m?
Sorry, the last one.
What sort of monster spells make file with a lowercase m?
Oh, come on.
Yeah.
You know, that is why I brought up this. I'm not a developer, right? Nerd.
All right, very last question.
This is another question that's longer than the answer, probably.
Always.
One use case of extensions is to hold the application code which is server side. So you have your application with the release version and also the server side part is an extension with the same name and the same version number. However, to install an extension, you need access to the file system of the server, which is not good for installing an application. Do you think it would be good to have a possibility to have extensions that don't require files to be pushed to the server, but they can be installed in some other ways?
That's a good one. It depends. Yeah, I don't know. It could be dangerous, right? So how much would you allow without having the access to the file system, right? So maybe I could imagine if you want just do something with SQL, like the first example, I think that could be fine. But if you start forcing like actual C code to the server without any, I don't know. I saw bad things. So let's see that.
All right, we're running out of time. Dirk, thank you very much for your contribution. I'm better prepared. So for you, also, I have the cool keychain.
Yeah, thanks.
And Floor, it's up to you to handle the debates. Hurry.
I'll take both. Hello? Yes. I'll take both. I need my four debaters here. Jonathan Battiato, Emra, Matt, and Dimitri, if you can join me here on stage, because we're getting ready for the debate. I'm so glad that I volunteered to run the debates. Please pray for me to keep all of these people in time. Take your time, Matt. We're definitely not in a time crunch, you know, all good. You're fine. All right, so we have two debates this PGDay Lowlands. The first one is going to be about Postgres on Kubernetes. Is that a good idea? Is it a bad idea? Is it a meh idea? Because oh, wow, you're getting ready. That's great. And my task again is making sure that everyone stays in time. Running Postgres on Kubernetes can be extremely beneficial thanks to advanced resource management and automated deployment, portability. However, now DBAs need to learn a whole new technology, and that could maybe hamper some of the innovation. Data consistency can also still be challenging. And our debate gives both proponents of Postgres on Kubernetes a chance to defend their viewpoint, but also people that are against. And hopefully it will lead to some really interesting hallway discussions when we're going into the break. Let me introduce our debaters for you. We have Jonathan Battiato, who is a senior software engineer at EDB and a cloud-native PG maintainer, and also a data on Kubernetes ambassador. We have Emra, who is a computer engineer working as an independent Postgres consultant at the European Patent Office. And then against, we have Matt, who is a customer engineer database specialist. That seems like 4 different titles in one, but okay, at Google, and also a Pokemon card collector, if you've ever seen his talk on that topic. We have Dimitri, who is a Postgres DBA at Atien, and I've been told that you've been described as the person, like hell will freeze over before you'll consider putting data on Kubernetes. So that sounds great, you know? That sounds like 4 really capable people. And so for our time, because we only have 20 minutes and I've already been speaking for 2 minutes, I'm sorry. Everyone will make their opening statement that cannot be longer than 2 minutes. Yes. And once we've done that, we'll start sort of like pinging back and forth. You've got your own stopwatch there. I love that. Okay, we're starting with the people that are against. So Matt and Dimitri can start. You're closest to me, so I'm giving you this microphone.
Раз, два, три. Okay, I'm Dmitry, I'm operational DBA, and I'm looking after really big and loaded databases in payments where the sub-millisecond latency is our target. And so I have a really, really long list of objections against the data in Kubernetes, especially Postgres in Kubernetes. I do not have anything against the Oracle in Kubernetes. But I have to choose just 2 points, and I had to. So the major for me. So the performance overhead that you have to, you will get from Kubernetes. So that you need to pay for network, I/O, and CPU. So, and it's not theoretical statement. It just goes from POC. So you will see the added milliseconds to latencies. And so in the world of payments, it's not affordable. So the second point is the cross regional setup. So it's not just possible in the modern operators. So with a regular DR, so you will have the replica in some far DC, and with a so it's not possible to have this stretched Kubernetes cluster across regions. And that's why you will have to have 2 independent clusters that cannot be managed by 1 or 2 operators. So it means that you will need some automation on top of orchestration. So I would not put anything really, I mean, data that I really care about under these, I mean, how to say, the homemade stuff.
All right, your team member?
Thank you. Hey, I'm Matt. So first of all, I'd like to state that I do understand why you think putting Postgres on Kubernetes is a good idea, given how amazing it is for stateless application. But honestly, I think the real question is not can you, but should you? And honestly, I think for 99% of the use cases, and probably 100%, it's a clear no answer. And I have three points to argue with that. So the first one is the operational cost. You are adding complex layers on top of your databases. What does that mean? That means that now your DBA, aside from being a good DBA, also have to be good administrator of Kubernetes. It doesn't simplify your life. It will just shift the complexity. Second point is about obviously performance, like Dimitri said. The more abstract layer you had, the more latency you will have to your database. And I'm not even talking about the day you will have performance issue, because good luck for navigating through different components and abstract layers to understand where the problem is coming from. And lastly, I think it's all about focus. Do you really want your DBA to spend their time navigating through complex YAML files, networking policies, config map, and so on, instead of focusing on what brings value to your company and to your users, such as, I don't know, helping them designing their schema or optimizing the SQL queries? And that's my opinion.
Beautiful. You can give it to your opponents.
I've been running my production Postgres on Kubernetes for the last 4 years. Sometimes I ask my other DBA friends, hey, why don't you consider migrating your own databases from conventional virtual machines onto Kubernetes? I've seen that most of the time, their reservation against Kubernetes originates from the misconception that the Postgres that runs on Kubernetes is not original. I mean, they think it's some sort of modified or customized version of Postgres. And this naturally raises some concerns on their side. You know, the uncertainties may always be a cause for concern. But here, I can assure you that no, this is definitely not the case. The Postgres that we run on Kubernetes is the exact same Postgres that runs on virtual machines. It's byte-to-byte, same binaries. We have a regular Debian Linux image at hand. We download the Postgres packages from the official apt repositories, and we install them on top of that Debian. And these binaries eventually run on a regular Linux kernel as well. So if you decide to migrate to Kubernetes, you will be working with the same Postgres that you already know and that you already love. In that aspect, there is no surprise for you. So what I recommend is that you just take it easy, give Kubernetes a try, test the waters, and hopefully you will see that you are liking it. Thank you.
Okay, hello everyone, I'm Jonathan, and they actually made good points, so don't run Postgres on Kubernetes. No, I'm not here to convince anyone to run Postgres on Kubernetes. I'm just here to tell you that Kubernetes is also ready to run not just stateless workloads, but also stateful workloads. There has been an history of improvement also in the storage side. Since I'm also part of the Data on Kubernetes community, I actually talk about the community that I'm part of. So we are collecting and gathering knowledge for stateful workloads and experience and organization that use Kubernetes also for their databases. We have many reports, in every year almost. We wrote a report that collects all the experience and how do you say that? The people, the organization and companies that use actually stateful workloads on Kubernetes. Also, myself, I create a GitHub repository for a project that I would like to share with you. It's a collection of tools and best practice guide to actually run benchmarks on stateful workloads on Kubernetes. That is, I started with Postgres, of course, because I know that. And I collect the guide for FIO, which is a tool for IO operations on storage. Also, I introduced PGBench and the PGTestFsync, which are part of the core of PostgreSQL for benchmarking PostgreSQL on Kubernetes. So you get the guide there. You can try yourself if that is a real solution for yourself or running Postgres on Kubernetes. Performance. So you get performance. You can actually have your own results and compare with other solution, different CSI, for example, different storage. So you can collect your own data and decide. So I don't need to convince you. You try, and you will find what is the best for you.
Perfect. After the passion of our Kubernetes musketeers are against, contestants can reply.
Yeah, so it's really hard to reply because I didn't hear anything, any benefit that we will get from it. What I heard that, so just guys try. Okay, so instead of it, so I just forgot one point because I was in rush. So I will use this opportunity. So it also comes from practice. I completed recently a couple of investigations with the performance investigations. When first case was misbehavior in the syscall, and second was some ghosts on the storage. If I did the same with the Kubernetes, I need to add to my investigation slow CNI, slow CSI, slow storage, slow the PVC. And so the time that I spent a couple of weeks with a normal bare metal setup, so with the Kubernetes, I would say I would take weeks and weeks. And I don't think for real production, for real high loads, it's an option. Sorry.
Sure. So I'm not as funny as Dimitri, but he's correct. There's no argument. Like, okay, you can do it. I'm not arguing that you cannot do stateful on Kubernetes, but the thing is, why should we do that? What is the benefit of using Kubernetes instead of just doing managed services if you want to simplify your life with operational burden, or using bare metal to have perfect performance? I mean, fine-tune and extreme performance as you like. That's the two options. And for me, Kubernetes, I mean, operators on Kubernetes for Postgres is the worst of both worlds. So I don't see the value of it. Also, you said it's the same Postgres. I do agree, but again, my point is not that this is a different Postgres. It's a different way of managing Postgres, and I don't see any value in it. I'm trying to search through arguments, but I think I'm good.
Cool. Our two contestants in favor can reply.
Our friends here have voiced arguments against Kubernetes. Actually, I might perhaps agree with some of their statements to a point. When you migrate to Kubernetes, it will not be all sunshine and rainbows. You will definitely face some new challenges that you didn't know before. However, the main question we need to be asking ourselves is, as the DBAs, can we really manage to stay away from containers? Let me tell you, containerization is not a hype technology. It's being used for more than 10 years, and it's here to stay. Today, it will be fair to say that the paradigm in virtualization technologies has shifted from hardware virtualization to process containerization. And databases simply cannot stay out of this development. They will have to adapt. When it comes to Postgres, the good news is that we already have long-standing operator projects that integrates Postgres with Kubernetes. These are open source projects, and large companies like EDB or Zalando are contributing to them as well. Postgres operators is not experimental work. They are being used in many production environments. They are battlefield tested. So my final words is that you may simply be happy with your current virtual machine environment, and you may not be looking for a new adventure. However, just do not completely shut yourself down to the idea of Postgres on Kubernetes. All right? Thank you.
Thank you. Also, to answer all the doubts about the pros and cons of using Postgres on Kubernetes, well, the improvement will be declarative configuration and deployment, immutability, and also running Postgres in Kubernetes close to the application, reduce latency. And with the operators, all the operators that you might find for PostgreSQL allows you to have really high availability and self-healing with the failover, automatic failover. And also responding to, regarding the the possibility to have a cluster replicated to another Kubernetes cluster that we made as a cloud native PG. We made a solution that is a workaround for the limitation currently having in the Kubernetes, which is the not federated, since Kubernetes is not federated with other Kubernetes clusters, we realized that we needed something to make possible cluster different in different Kubernetes cluster to communicate between them and replicate. So we have Postgres Kubernetes Postgres cluster in CNPG that is replicated by another cluster outside Kubernetes. Sorry, outside the same Kubernetes cluster, so in a different Kubernetes cluster. That with a topology architecture, you can create for example, three data center replica clusters that can replicate to each other and decide which to promote and to demote as a replica cluster every time you need to do maintenance on the data center. And that requires also, of course, really consideration around the bandwidth of the network, because if you have data centers all around the world, it's, of course, you will pay the latency between the replication. But that, yeah.
Perfect. And we're here at PGDay Lowlands. That means we're in the Netherlands, and a really important political framework in the Netherlands is a polder model. That means that we need to come to some sort of consensus. You know, we need to, so I will give you just a little bit to discuss with each other. If we can do one closing statement that reflects the polder model, please.
Altogether, you mean? Postgres rules?
Postgres rules. Okay, sure. Fine.
Yeah,
I'll
makes
take that
sense.
one. Thank you so much for your participation. All right. I believe we're going for a small break. When are we supposed to be back, Dirk? You know this by heart. That's why you immediately say the time. 10 to 4. Great. See you all back 10 to 4.
Rotterdam 2025.
PGDay here, Rotterdam, yeah. 20 to 5, Lowland is live. PGDay here, Rotterdam, yeah. 20 to 5, Lowland is live. PGDay here, PGDay here, PGDay here, PGDay, 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 PGDay here, Rotterdam, yeah. 20 to 5, Lowland is live.
Welcome to PGDay Lowlands, Rotterdam 2025.
20 to 5, low end is live.
Welcome to PGDay Lowlands, Rotterdam 2025.
PGDay, PGDay here, Rotterdam, yeah. 20 to 5, low end is live. PGDay here, Rotterdam, yeah. 20 to 5, low end is live. PGDay here, PGDay here, PGDay here, PGDay, 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 PGDay here, Rotterdam, yeah. 20 to 5, low end is live.
Welcome to PGDay Lowlands, Rotterdam 2025.
PGDay, PGDay here, Rotterdam, yeah. 20 to 5, low end is live. PGDay here, Rotterdam, yeah. 20 to 5, low end is live. PGDay here, PGDay here, PGDay here, PGDay, 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 PGDay here, Rotterdam, yeah. 20 to 5, low end is live.
Welcome to PGDay Lowlands, Rotterdam 2025.
PGDay, PGDay here, Rotterdam, yeah. 20 to 5, low end is live. PGDay.
Right. Thank you very much for returning to our next and last session. I hope that you have been enjoying the music. One thing that you will know for sure is that I didn't compose it, because if I would have done it, it would have been something much heavier and metal, as you know. But if you want to give us feedback about the song, about the conference, about the catering, the feedback is open. You can provide as much feedback as you want, because we want to use that information to improve for the next year. Now, if you are happy, for instance, about the quality of the sound and the quality of the image and the lights here, you can thank that to Mart and Jeroen. They're there. People behind the scene. Now, our next speaker, coming directly from Ecuador, but actually from Spain, so she will tell us exactly from where. She does a hobby that I think that not many people here in Postgres community do it. She is a belly dancer, and she does pottery. So maybe we can find a combination of people who can do at least one of the two. And she's going to be talking about a love story, a data love story, going from MongoDB to PostgreSQL. So please welcome Valeria Aro.
Thanks, Boris, and thanks for coming. I hope that you enjoy the romantic stories, because I am going to use love to reflect our feelings, our emotions, where we are choosing a main database. And it is related with the two popular databases that are PostgreSQL and MongoQL. Let me introduce myself. I am Valeria Aro, and I guess that the most important thing is that I have been working in Datamaran company for 8 years. So that's the reason why I can share the story today. So as I mentioned, the stages of love reflects directly in the way that we feeling when we were choosing our main database. In a human relationship, when you found someone, this person that has good qualities, you think that you are compatible with them, is matching perfectly with what you are looking for, you just fall in love. You have high expectations about this partner, but once you begin the relationship with this partner, you realize that nothing is perfect. You analyze the things, and now you're entering a disillusioning stage where you just know that this partner has weakness and strengths. And it's in this stage where you need to decide. Continues with the relationship. If you love it, you just accept your partner as it is, and it means that you found your true love. But if not, just break the relationship and continues looking for. So for context, the Datamaran company has been founded 11 years ago with one idea to use data to help people in the sustainability topic. So this idea was unique in that moment, and it was in building. So we wanted build a product that is flexible, is adapting to how the evolution of this topic is going, and of course, we wanted a database that is flexible as well and provide us a faster prototyping. It's easy to use, and obviously, as it was a startup, we wanted something that is cheaper. So when the questions about who database we will choose, we have a lot of options, but as our main requirement was the flexibility, we just fall in love with Mongo database. We started the relationship with a Mongo Atlas database. And let me share with you what we love for this partner. In reality, we receive what they propose with this database. No, we have a flexible schema. I have the sample here that we have different elements in the same collection. I have a collection that is organization, but inside that collection, I can have documents like this one that is for a lucrative organization that contains the industry, where is this organization based, the name. But in a special case, only for United States, I need to save the CA key value that is identifier for them. So I can have these different models inside the same collection and not created null values. And additionally, I can have NGOs in the same collection that only contain few common values with it. Which more we love, that we can quickly prototype everything. As you can see here, we create documents that contains our data that we require for charts that is showing to the clients there. So we don't need to compute or calculate it when a client goes to the application. We just have the data already there ready. So it is really faster to read and write. Additionally, as we were prototyping these, normally we started with the idea, okay, I wanted a model that is just reflecting a one-to-one relationship, like in a relational database. But it was really easy for us just change it to a one-to-many relationship. It was just a debug data script that convert the object or the string to a write of objects or a write of a string. And it was just directly doing in the database. And in the application side, we didn't know that it was changed because the query still is valid. Another thing that we really appreciate for MongoDB is the TTL index. It helps us a lot to automatically set up archives or clean up in our collections. You just need to set up a timestamp field in the collection, and it is going to work automatically, as I mentioned. And this TTL index and not having to take care about the schema changes or managing the schema just make us that we can create easily a recovery process. If the user deletes something, just in special cases, we just move the documents directly to a trash database. And we keep it there for 30 days using the TTL index. And it was really useful for some special case where the user don't want it to delete, and we need to just go to this database and recover the data if the user made any error. Let me continue. Additionally, I will say that MongoDB is always up to date with what the market needs. They provide us Mongo Atlas search that is based in Lucent. So practically we replace what we have it in Elasticsearch in MongoDB. And they have vector search as well. Another feature that we didn't know that we needed is Mongo Atlas search. And with a few clicks and just writing a query, you have a faster way to create charts, refresh them in a different scheduler, 1 day, 1 week, whatever you needed. And you can embed those charts inside your internal applications or just share that dashboard with the business people. But not everything is perfect. And I am a Latin woman, so we need drama in the stories. And the company start to growing. We have more people, we have more teams working together in new functionalities. Let me show you what we found with the database now. That we found data anomalies. We created those. So as Mongo at the beginning, we thought that it's schemeless. Nobody need to take about the scheme, right? So it was happening to us. But when we found problems like this, that in theory you are waiting for an integer, but in the application it appears a string, voila, the application is complaining about it, you are getting a lot of errors, and it is happening the same because we were requiring some mandatory fields that is not appearing, so errors again, and non-standard values, blah, blah, blah. Similar things that we know that in a relational database it is easy to fix it because you already force a schema there. But I will say that it was our issue in the company because we understand badly what is MongoDB. And MongoDB already provides something that it's called schema validation rules. So you can use this functionality to define the schema and try to avoid this error. But obviously, you continue having the flexibility to add in whatever you need, and the new things can bring this problem to you. And the database was growing. We need to link data. And in Mongo database, you have two approaches to do it. One is using the lookup operator. So it means simulate the join in a relational database. But the problem with that one is that it was too slow, bad performance. And just MongoDB did some improvements in 2021, but we are using longer database, so we just go for the second approach to link data, that is embedding. It means that you duplicate data. You have a document, and if you link to another one, you just copy the data that you needed for this and put inside your document, and you have in one document everything you needed. And it is totally fine. And we didn't realize even that we have an automatic process that create historical data for us. I am having here a sample. We are having the Facebook database, Facebook company, sorry, that if I execute some years ago my sustainability analysis taking this company in mind, I will have my sustainability data with the name of the company Facebook. But we know that the company changed the name a few years ago. And what we do, update in the organization, right? What is the problem? Those documents are not updated. If I create a new sustainability analysis now, it is going to appear Meta Platform. So if I wanted to do any analytics over the sustainability analysis to see how many times I am using meta platforms in the sustainability analysis, you are going to get a ground response there. So it's easy, and I will say that it's okay in this case because it's just data changing, no? But sometimes the problem is that users made errors and they enter wrongly the data. So if we need to fix, we need to know where organizations are using to trigger update synchronization in all of these documents. So it is hard to maintain. And obviously, we know that in a relational database, we don't need to take care about this because we have foreign keys. And it happens the same for a delete. So if I delete now this company, and if I don't control well my scripts to delete it from all the sustainability analysis, it is going to still appearing. And it is just creating about the data consistency. So we have too many scripts to validate the data across the database, but we were just seeing that it was not something that we can continue maintaining. And another big problem when you have developers that doesn't matter about database is that we just have data models out of control. What it means, as they wanted just to read and write directly for what they needed in the interface, they put documents like this. This is one simple one that I found, because if not, they don't enter in the screenshot. But even you can see it, that we have one array that is containing objects. This object contains array again, object again that contains array, that contains objects. That's crazy. So it is fine in some cases if you just read and write the data, but if you wanted to query something in the nested values, when you have multiple nested levels, it's a really problem for performance. And finally, what I could say is that for the developer experience, MongoDB don't provide a good solution for us because we are using Mongo Atlas. And all the key things that we have, like triggers or the Atlas search or the vector search, is depending of this cloud environment. So what it means that if we wanted to deploy something for a developer locally, we cannot do it. And that's a really problem. So what we have right now is just a shared environment. All developers sharing the same one. And obviously it causes conflicts because if you delete something that the other is waiting for, it's a really pain. So what you can see now is that in reality, Datamaran growth as a company, the requirements just changed. We are not focused now in a flexible schema. What we need is a data consistency and data integrity, and obviously something that help us to fix this problem with environments. And something more that it's adaptable with the new data types that we are using it. So it was not hard to choose the next partner. Let me tell you what we are loving now for PostgreSQL. We are just falling in love. And we have databases templates in Postgres. So it helps us a lot to create those local environments that we were dreaming. We have Docker machines that is just creating this template, and everyone has the database in their environment. And we have, with this same feature, we just integrated this process inside the Bitbucket pipeline. So everything now is testing in our repository. So we don't need to take care about the bugs appearing or so, because we are having a robust system now. And we are using it, something that is risky, but for now is good for now, that is logical replication. So sometimes data import when you are running some special test. So to avoid bugs, to have a special environment is really equal to what you found in production. We have a pre-production environment using replication. And obviously we are just now discovering a lot of extensions. For now, we are just using pgcrypto, pgvector, and pgcron. And yeah, it was not a really easy decision because we have too many challenges to move from MongoDB to Postgres database. The first main problem is that our application was a lack of data layer. So it means that anything that we wanted to migrate to Postgres needs to recreate the code and obviously design the data as well. Right now, what we have is just applications that are using the two databases to don't break our systems. We are not using migration tools because what we saw in the market is that normally the behavior is in the other side, know that the people is moving from Postgres, some data to MongoDB, but we are in the other way around, so we created ad hoc scripts. And we had to depreciate the functionality that I mentioned for recovery and self-delete, because now in Postgres is something that we can manage, but we need to spend more time and more effort to make it work. And finally, the developers obviously need to adapt with a new database, new way to think in design data, in how to use queries and so. We are using Postgres for almost 2 years now, but we don't find too much problems there. Just what I can mention is that we need now to manage the users, and we know that the way that it's doing in Postgres is that the user is the one that creates the resource, is the one that is the owner of the resource. So we need to understand that concept, but now it's got it. And another problem that we have is with the connections handling, having maximum connections in the application. We were just saving now in the application side. As I mentioned, having this logical replication is a risk. And at the beginning, when we were applying this system, we just made an error and we were having a problem for a couple of hours. Fortunately, we just not having a lot of applications in that moment in Postgres, so we were fine. So to finalize, let me tell that we just think now that we found our true love with PostgreSDB. And we just are doing better things, because I guess that even in a human relationship, when we have errors with your previous partner, you are trying to do it better with the next one. And what we learn is that myth that is that we have MongoDB like a schemaless is grown. You need to define a schema in a way to don't have the problems that I mentioned today. Obviously, teach to the developers the best practice to use any database is always something that is going to be in favor for you. And finally, what I don't want to conclude is that Postgres is better than Mongo. That's not true. Or that Mongo is better than Postgres. That's not true either. I guess that it's just different databases for different use case. We are still using the both ones. And I would say that MongoDB was really useful for us when we were a small company, prototyping, just focusing on a small domain. So it is really a good one in those cases. But now that we need a centralized database, we have a solid product, and we are prioritizing the data integrity and the data consistency, is Postgres your partner. So thank you very much. I am now open for questions.
Thank you, Valeria. And we have time for questions. Does anybody has a question? Just raise your hand. Otherwise, I have a few questions. I'm going to start. So when you were discussing about MongoDB being able to do some type checks or the schema checks, but you realized a little bit later, are you using something like that in the JSON objects in Postgres, or you are just using columns and data types that guarantee those kind of checks?
We are avoiding to use JSONs inside Postgres, and we are trying to normalize everything. But as I mentioned, we are still having a hybrid system. So everything, all the data in reality is in PostgreSDB now for some systems. But after it, what we are doing is just synchronize it, documents at the end to MongoDB. So the application is still consuming Mongo to just don't change too much code for now, because it's a big challenge, move data and code at the same time.
Okay, thank you. Any other questions? Yeah, here.
What about your write performance? You know, the Postgres doesn't have built-in sharding feature. Did you notice any observable decrease in your write latency?
No, in reality, we don't having performance problems. What the unique thing that I realized is about size. I thought that in Mongo we are duplicating data, right? So I thought that it was the database in Mongo should be bigger, but no. Now in Postgres it's bigger because we are creating multiple data in different tables. And that's the unique difference in latency and those kind of things. We don't have problems. We are still using a cloud for it and in the same regions or so we are not having problems there.
Okay, thank you.
Good. Okay. So once again, we are going to give our nice handmade key ring to our speaker, and we thank her once again. So thank you, Valeria.
Thank you very much.
HDMI, you have your own goods. Okay, so this is our last technical talk or community talk, because then we have a debate and then we're going to have the closing. So what we are going to have here now is going to be a survey results, stories that he has learned just by talking to people, interviewing people. Andreas, probably you have seen him before in other conferences or just organizing stuff, speaking, or doing many stuff. Maybe you also know that he has two nice hobbies, running and cycling, but he always does it with a purpose. He just doesn't go running and cycling for the sake of doing it. He always goes to find ice cream. That's his goal. He runs to the ice cream shop and bikes to the ice cream shop, but he's going to talk about something else now. So please welcome Andreas Schermbaum.
Thank you. You know what's the worst part? After the ice cream, I have to run back. Anyone seen this today? You should go, you have a ticket for it. Okay, how many people in our community like sailing? Does anyone here like sailing? I should interview all of you. We will answer this question in a couple of minutes. Since 2020, I'm doing a small side project, not so small side project. I'm interviewing people from a Postgres community. This is the website to the interviews I have. The main purpose of this is actually bring people, well, to you, to let you know about these people, and not just the committers we have, not just the people who are writing code, but anyone in the community. Like people organizing the conferences, like people helping others online. Well, thanks for the introduction. My name is Andreas. I'm actually also board of directors Postgres Europe, so technically we are organizing this year. I'm one of the founding members of Postgres Europe 15 years ago. How long is it ago? 2008, I think. These days I work for EDB on Warehouse PG, which is a Greenclamp fork. So we care about anything which is a terabyte or more, anything below that. It's not really our thing. You mostly can find me on Mastodon or on LinkedIn. I also have my own blog, which is not the same as for the interviews, so different URL. And I also have a website with all the social media links I have from the interviews and a couple more. So you can add your own social media links to this website. If you go to this link, anyone I interviewed and many people more, all the social media links I have, you can just go and follow them. Small side story, we also have an event calendar. So if you want to know about this event next year or other events we have, there's a work calendar you can add into your Outlook. And then it shows you both the call for papers we have and the actual events. So you will never miss a deadline for submitting a paper. 1, 2, 3, 4, 5. Okay, coming back to the interviews. What is this about? So I will tell you a little bit how it started, how this is going on. I will skip over most of the technical details because I got short to 25 minutes here. And then I spend the larger part of the talk about what I learned about the community, about everyone I interviewed. Anyone know what this is or where this is? Ideas? Gianni is not allowed to say. It's the Supreme Court in Rome. Anyone knows this one? It's close by in Sicastus and Angelo. So how did this start? 2019 in December, we've been in Rome with a couple other people, among them Devrim over there. And then we're sitting in a hard rock cafe, Devrit's favorite place of all places. And well, we took pictures, we were sitting over lunch, and then discussion started what we can do for the community and how we can improve all of this. And then we came back home, and as you may remember, shortly after, December 2019, the small breakdown started and we had to stay home. I had some time to implement this. Anyway, I started asking a couple of people, can I interview for this? Build up a website, started the interviews, and then all of this started. Why is it not working? On a technical side, it's a static website. So I'm using Hugo under the hood. It's deploying from Markdown files into an HTML website. There's a repository I'm pushing to. It's automatically deployed to the website. Everyone I'm interviewing gets a Google Doc for the questions, so they can edit questions, answering questions, add new questions any way they like. There's at least one round of reviews, usually more than one. And then once they're happy, I create a preview. Usually there are some more changes coming in after that. And then once they're happy with the preview, it gets published at some point. It's usually published on Mondays. Then I also post on some social media links. And as you can see, every time I post something, I get more invites from people I don't know. I also learned the hard way that LinkedIn is removing invitations after 6 months. So that's why it's going down again. How many people like to call it Postgres, or how many people like to call it PostgreSQL? It's evenly split. So this number really doesn't change. So the majority is, small majority is in favor of PostgreSQL. No one said PostgreSQL. That's good. There's, however, only a very small minority to actually say, let's change this. People are just fine naming it Postgres or PostgreSQL or whatever. So I think the project will just stay with it. How many people did I interview? So I started about 600 interviews. Out of this, I started 230. I have 600 people on my list. Out of this, I have 208 completed and 124 open. So anyone here in the room who I asked to interview and we started, please complete it. It is completed. Good, soon. If you want to suggest anyone for an interview, any way Postgres related, please drop me an email, drop me a name. Ideally also include an email address, please, so I can contact this person. There's one person I got recommended 12 times. Can you guess who it is? Close, I should look up this number. It's actually Tom Lane. Well, he said thanks, but thanks. From the entire community, what are the top 3 countries we have people from? Germany, no. USA, France, India. And France is really a top runner up to the US. So we have, how many? 25, 27. Yeah, Uno. Yeah, make it more, make it 2. Where's Chile? Chile is one that's Alvaro, actually, yeah. Make it 2. I have a total of 34 countries where are people coming from. That's impressive. What's the first Postgres version people are using? You should really go and read the interview with Elaine Mustaine, who worked for the original company who used Postgres before it was Postgres 95. That's a long time ago. What's with 14 and the other versions? Why are we not getting new people into the community? And we really, really need to work on improving this number. So this is always about 15, 20%. It's never getting better so far. So please give me more names. Please include more people. That's coming back to my initial slide about sailing. So we have 5 people who at least told me they like to sail. I've seen a couple more people here in the room. The big winner by far is cycling. So plenty of people actually go out and do cycling. Walking around is good, hiking is good. We have a running club. We also have a chess club in our community. Where's the chessboard? Yeah, usually you see him playing chess at a conference. So, Dirk. There's also a couple of people who like to actually build Lego. That's nice. If you stay at home, I think it's evenly divided between watching movies and reading. Is anyone doing both as a favorite hobby? And coffee is still the strongest drink we have, outweighing beer and anything else. Where are people? Where can you find people? Twitter is still very strong, so occasionally I look over all the interviews and check if the Twitter account is still active. Quite a few people are actually still on Twitter. LinkedIn is rising, so if you want to find anyone in the community, probably these days go to LinkedIn. This matches with data we've seen from the other events we have. People tend to go to LinkedIn to find the information about conferences. Mastodon is rising, and blogs are also rising again, so people started writing more blogs. For a while, a couple of years, it was kind of declining. Now it's increasing again. Okay. What's your favorite conference, except Lowlands? Still Lowlands. Okay, second favorite. Yes, PGConf is by far the most favorite conference for people to go. I can undersign this. And then it was PGCon, so now it's PGConf Dev, this one. And then it's also FOSDEM. Anyone been to FOSDEM? And the others, why haven't you not been to FOSDEM? Okay. We have a total of 34 conferences in the community, one way or another. So if you want to find a conference, you can probably find one every 3 weeks. What's your favorite extension? Yes, this matches. We have a total of 62 extensions. Only mentioned it in the reviews. We have way more in the community, but 62 mentioned. So yeah, it's PG statements and PostGIS mostly, and then it's decreasing, coming lower. I have 208 interviews, and more than half of the people in my interviews make a career out of Postgres. Looking back 10, 15, 20 years, could you have imagined this? Oh, actually, yeah. Does Postgres have a future? Well, I don't know, but people say it has a future. So about 2/3 or 3/4 of the people in our community say, okay, yes, Postgres has a future. I didn't hear any other opinions. Is Postgres good for your business use case? Yes, otherwise we wouldn't be here. Is Postgres also good for your private use case, for your pet project, whatsoever? Most people say yes, but the number is a little bit lower. Some people, a few people actually in interviews say, okay, maybe use something more easy, maybe SQLite or so. Doesn't always have to be Postgres. Last question. Do we need multi-master? Who's in favor? 1, 2, 3, 4. Oh. Who's against it? Who doesn't care? Well, we have 7 people who want it. I hope you get to it and actually implement it now. I'm pretty sure they didn't. Okay, yes, plenty more data in it. I don't have time to look over all of this. I could go on for another 2 hours or so. Any questions? And before you answer, I answered a few of you already. Yes. I did hide a few. Yes.
For how long has Boris not answering the form? Because the last time he was a year. Is still counting?
Yeah. He needs a project manager for this.
Bruce has a question.
How did you exceed your own slide count?
That's for you to know. The presentation is longer, but I did hide a few, and apparently LibreOffice can't count.
Okay, do we have more questions?
Yes, Devrim had one.
Who?
Devrim.
You have a question?
You did raise your hand.
He already
Okay.
asked his question.
Okay. Thank you.
Okay, thank you very much. And wait here because I have to give you your... Yeah. So I hope that this is going to come into what is one of your favorite speakers present. Handmade keyring for you. Thank you again. Okay, so after Andreas, we have the last debate, which is going to be, if you were worried about the temperature in the room, it's going to be now even heavily increase the temperature because the next debate promised to be one of the most epic debates since the start of the debates in the Postgres community, which means since the previous one. Yes. Okay. So I will let the floor to Floor.
That's just painful, dude. All right, I want to invite my debaters on stage with me, if they feel like it. It'd be great. Luigi, Gianni, Mayuresh, and Guy, please join me on stage. And just to reiterate how seriously we take feedback, I got some feedback after the last debate, so I'm going to implement it immediately. Just before we get started, I would like to have a little show of hands. Auto-tuning as a topic. Anyone in favor, please raise your hand. We love auto-tuning. Yes, yes, yes. Anyone who's just like, nope, not for me, not for my data. Okay. This is not a 50-50 split. I'm just gonna, I'm just gonna say it as I see it. All right. So Auto-tuning brings a lot of advantages to the database performance and maintenance. It can save a DBA hours of manual work, and it outperforms all of us fallible humans. But who can guarantee that algorithms have been optimized for your particular use case and won't create extra overhead? How will you onboard new DBAs into your automation scheme and make sure that they understand the possible side effects? Now that we had a quick temperature check of the room, let's see if our participants can change your mind. Our participants today, thank you for putting that timer there, are Dr. Luigi Nardi, who's the founder and CEO of DBTune. Maybe he has some skin in the game there. Prior to DBTune, he was a professor in AI at the Lund University in Sweden and part of the research staff at Stanford University in California. Oof. He worked on auto-tuning since 2007. And in our briefing call, because we had a short briefing call so that they could get to know each other a little bit better, Luigi did mention that there are a couple of things that he wouldn't auto-tune today. So I feel like he's already warming up to it. It depends somewhere in this debate. Then we have Gianni, who is the Global VP and Practice Lead High Availability at EDB. And our participants that are not very keen on handling control to an agent are Mayuresh, who is a database specialist at Veeam, and Guy, senior database architect, technical lead, and partner at Zebanza, a man, in his own words, who doesn't like any surprises. Maybe understanding why he doesn't like auto-tuning. All right, all participants have the opportunity to make their opening statements, and they shouldn't use more than 2 minutes. And I want to start with our participants that are opposed. So, Mariusz.
Thank you. So my first opposition is that ChatGPT lies. LLMs are probabilistic, and databases are supposed to be source of truth. If you use LLM to tune your queries, change your functions, you will not have the same results that end users expect. So you're distorting truth. AI has no concept of truth. And the second problem is end users, they require stable and predictable performance. The end users care more about having same performance day in, day out, rather than having few percentage of improvements. With LLMs, and if we put this in optimizer, if our optimizer becomes intelligent to do runtime changes in, say, it takes hash join, nested loop, merge join whenever it wants, we already have evidence that it doesn't work out, because if in case of Oracle, we have adaptive optimizer, and if you Google Oracle optimizer adaptive plans, second link will say disable for performance. That's my.
Excellent, excellent. Let's hear from Guy.
Okay, some very good arguments there, because I'm agree with him. So I have to not invent other ones, because I still have some other ones. First of all, auto-tuning. I believe in tuning, don't get me wrong, but I still want to have to control, or at least someone has to decide what we can tune, and not automatically some software, because most of the time it's software, it's developed, and he's a very smart guy, but he said, I'm not going to tune everything yet. So that's very wise. So not everything tuned yet. That's very wise. So, but anyway, most of the time the software doesn't know overall everything about your system, because it's about your system. And finally, the end users, they will see, and they have to work with the system. Yeah, and I don't like surprises. That was one of my sentence that I used in the meeting. And also the users, they don't want any surprises. They expect to have the same kind of reaction workload that they can have like the day before. Yeah. So, and also the lack of awareness, meaning, for example, is there a new release of the software that was installed by the development team, probably the queries will be not the same like the day before, and they will be working differently. Maybe better, let's hope so, that they tuned on the pre-production or the acceptance and whatever. Yeah, but most of the time there is a query that is not performed like before. And then the tuning has to be done again. So auto-tuning has to work again. So on Monday it will work not good, maybe on Tuesday, maybe on Wednesday, and the end of the week, the auto-tuning did its work. So I want to be before there. Yeah, I want to see and work together with the developers and say, let's test your software also with stress tests or whatever tests before you put it in production. So that's the reason I don't want any surprises. So also the extra workload, I don't know exactly because I worked with software before. Yeah, the extra workload, machine learning, whatever, you need an extra software, you have to install it, you have to maintain it and all that kind of stuff. So I don't really believe yet that there is auto-tuning software yet available that can do very, very smart things already. So I think we still need control, or at least someone should decide, a human being with the right knowledge should decide what kind of modifications we should do on the database settings.
Excellent. Thank you, Guy, for your team. Oh.
All right, so first of all, I would like to talk about fundamentals. Not what's here now or in a day. I would like to talk about like the fundamentals of this. Can we actually solve this problem in a fundamental way? Okay. So first of all, when I do tuning, when I talk about tuning, I talk about, usually I prefer to think about some KPIs, key performance indicators, that need to be defined, probably with some stakeholders. And these KPIs can be things like one query ID, for the query response time of the query ID, or maybe the average of all the query IDs that you have, but also things like safety, like things like, for example, don't use more than X% of memory, otherwise you will damage the machine, right? So these are KPIs that need to be defined somewhere. And for me, that's the input of an auto-tuning system, okay? Second of all, I would like to talk about AI, maybe an automation, but I don't want to really talk about AGI, right? Artificial General Intelligence, which is what I think has been described a minute ago. So an auto-tuning system for Postgres doesn't need to speak English, maybe. It needs to speak Postgres. It needs to understand the domain of Postgres. So we don't need to solve AGI to be able to create an auto-tuning system. So human beings like us in history have been really, really good at solving problems that have been always considered like impossible. And one of my favorite examples is the Google autonomous driving car project. So think about a decade ago, everybody was saying, this is impossible. We're not going to solve this. And today, there are 5 cities in the US. This is expanding to New York City. This is expanding to Tokyo and Japan as well. And for me, once that we define these KPIs, whether you're doing it manually or you're doing it without the tuning, you really need to stick with those KPIs and you need to deliver on that promise. That's a contract that the user is making with the tuner. The tuner can be a manual tuner or an auto tuner, okay? So in the same way, Waymo is really redefining what's possible in the transportation industry. I think that there is an opportunity here in this community to redefine what's possible in database performance, to define a system that is not only effective for tuning, but fundamentally safe. Thank you.
Let's give 1 minute to your team member.
In a sense, this debate is similar to the previous one about Kubernetes. On one side, we want control. We don't want to learn a new technology because it's sufficient where we go. On the other side, there is a way to automate some things and to adopt consistently repeatable practices. And by culture, I tend to be in the field of repeatable. I never had the background picture on my laptop, but this week I put the TPA team group picture because I like people that make automation software. Now, coming to the point of auto-tuning. Postgres already has auto-tuning. In fact, there are parameters that have been removed in history of Postgres when we found a good algorithm to auto-tune them. Right? So it's not like every revolution, it doesn't happen exactly at the time that we established, but it starts gradually before and it continues later. In the specific case of maybe car driving, I don't know, but in database tuning, also I don't drive a car. But the databases, I have a bit more experience. And auto-tuning of databases is especially easy case because on one hand, there is it's a domain where we have a lot of ways to see if we did well or not. So even if we don't understand exactly what AI did, it's easy to measure if there was an improvement. And I think people like surprises when they're positive, you know? It's not like they don't want them. My customers, at least, they do. And
Gianni, we were afraid that the two Italians would run over time, and you're running over time.
Oh, really? Oh, sorry, apologies.
Your
I think it's
opponents
sufficiently funny.
can react to your statements.
So something about people liking surprises. People like surprises, but they want those surprises to continue again and again and again. Then it becomes a routine. And with auto-tuning, you can't have a routine, and you're asking it to be stay. Again, end users are going to ask you to be stable, have a stable performance. You gave them surprise on Monday. No, now they want it on Tuesday as well, Thursday as well, Wednesday, and it becomes like stable performance improvement. That's one point. And second point, I forgot to mention that if we don't win this debate, then Skynet takes over and humanity is extinct by 2125.
Okay. Guy, do you want to add to that existential dread?
Yeah, okay. Indeed, Judgment Day, I don't know. A good point that you just told us, because the Google Drive over there, or the car, was driving autonomously, but was it the most effective way and the most secure way and the most fast way? Will there be a car in Formula One? I don't think so yet, because the software, they have to decide what to do, and it will take time and it will take resources to decide what is the best. So I'm not going to buy that car yet, and certainly not at 200 kilometers an hour, because that will be dangerous. So I still have, or I want, to have the control of my car also. So that was a very good point to say that the car was there, but again, it was maybe not the most optimal way to do that. I agree with the monitoring tool, because we need, and we probably all have monitoring tools, yeah, but also trending tools. And there we have the KPIs, and we need them, yeah. But I don't want that software will decide, because the software, again, doesn't know on the complete environment what happened. We are not talking only about a Postgres database. That's our favorite database, yeah? But there is also operating system. There is also networking. There is also storage, and also the software somewhere on a different server, and we don't have a complete overview about that whole system. So if we're going to tune, there is also only the Postgres that we can tune. And I think we can better work together with the developers or with the software vendors to see what the overview is and what will be released in the new version. And then be proactive and tackle the performance issues.
Excellent.
Okay, so I'm not sure I'm fully following this safety aspect of autonomous driving cars. I thought the example I was trying to make is, this was a project that was considered impossible 10 years ago. Today it's totally possible in also quite messy cities. Okay, and it's way safer than doing manual driving. Okay, so that was the point I was trying to make. Anyway, so the point I wanted to kind of stress out a little more is, in everything I heard here, there is nothing really fundamental that hinders automation in this space. There is nothing really that, you know, you cannot engineer. It's a complex problem. It's a very complex problem. In the same way, you know, the Waymo car project was a very complex project, but there is nothing that is fundamental that cannot be solved with some really hard work and a lot of wisdom.
Yeah, I think so. And to continue on that sort, right? We have a lot of difficult problems to solve. Tuning parameters is not necessarily one of them, but there are lots of ways to use brain power of experts, which is not repeating the tuning 1,000 times if they have 1,000 different databases. Plus, I think sometimes what prevented us from automating more in Postgres is that it's difficult to find the actual formula, the actual rule, the actual algorithm. And if we find the rule, it will not be put into Postgres unless we can prove that it's optimal, because we cannot put in Postgres a decent but not perfect rule. We cannot automate it unless it's the best. And I think AI has really this quality to be able to optimize things even without understanding exactly how they work, especially when you have a way to measure if your optimization was positive. So in a sense, I see it as the same way we don't deploy things by hand anymore, right? Even, Kubernetes is a declarative system where you specify what you want to get, and then you let the system find out. But even the query optimizer, you write select, you don't write do this, do that. That's the optimizer that takes all these decisions. So we already delegate a lot to the machine. And I fear that we shouldn't have a ideological fear prevent us from delegating the last bit.
I want to take a quick temperature check of the room. Has anyone changed their minds after listening to these opinions? Okay. Interesting. I will not ask in which way. I explained the polar model before. I think we need to come to some sort of consensus. That's very important here in the Netherlands. So I'd love for you to quickly collaborate on a statement, an ending statement for this debate. And time is up. Yeah. Who wants to?
Well,
I trust you have a. Yes,
it
exactly.
looks like
the doctor.
in.
Oh, excuse me for not
then
titling you correctly.
No, but I'm less.
Less doctor.
Right. Okay, I'm the most doctor, so I'm talking. Right. So, in some sense, debating is great, but I feel that there is quite a lot of overlap between this 2 here and this 2 here. And I think that we want the best for Postgres. We want to do it safely. And we're conscious that now in 2025, there are a number of things that can be fully automated, and we should certainly do that. And maybe there are some things that we should work a little more on. What are those things? Let's brainstorm together and solve them one by one, okay? Thank you.
Thank you. Thank you so much for participating in this debate. A first time for PGDay Lowlands, so very brave. Thanks again.
Actually, I can't believe it's already Friday afternoon. It should be Thursday. I don't want to comment on that, but today passed by so quickly. Yesterday around this time, I was bloody nervous for what was about to come today, and now it's already behind us. Time flies when you're having fun. Magic. What are you doing? It's ready. Okay, cool. Yeah, I don't know how about you, but I had a great day. Unfortunately, I was not able to see all the talks, but I love to see you all here. I think it's really cool to see a group, like a room full of people, all sharing the same love for the Postgres. Some new in the community, some already here for a very long time. And for me, it was a great day, and I hope you experienced the same. Yeah, this is the organizing team. Unfortunately, not all of us are here. But I would say, for me at least, it was an amazing team to work with. So I want to thank you all. And please give them a good round of applause. And the program committee. It's one of these things you only realize if you start organizing events like this, that there's so much work to be done. And picking the talks can be quite a big task. And I really want to thank the committee who did talk selection for today. I think they did an amazing job. So please give them a round of applause. And this one is also, I don't know, before I was organizing things, I was like, do you really need these things? And how important is this? And these are the questions I naively asked when I started to organize this for the first time last year. And it is important. It is really important for everyone to feel safe, to have a safe place, to be able to speak up your mind when you really have to. So yeah, I would desperately want to mention Jos and Floor. Where's Floor? There's Floor. Thank you very much. It is a really important job, so thank you. And yeah, what can I say? I changed the pictures, Boris. What happened to my picture changes? Well, please, thank you very much, all the speakers. You did an amazing job, and I hope you had a great time, and I hope you all loved watching the talks. So thank you very much to all speakers. And of course, the debaters. I think it's a bit scary sometimes when you organize a day and you have a very limited amount of time. And then you want to try something new. And you have to take a risk, right? Because if you never take a risk, nothing ever changes. And I think we took a small risk here, and I think it was really cool to see these people. We can have panel discussions. I think panel discussions can be a bit bland, and it always ends up with, it depends. Yeah, we have something here and something there. And I like this idea. And I think Boris pushed this idea within our team. And it's like, you should be either on this side or on this side. And then we see what happens. And I think we got what we hoped for. And I hope it sticks around. And please fill in the feedback, what you think of the debates, because it helps us in making more decisions in the other years. So thank you very much, debaters. You did a good job. It was new to all of us, and you did a good job. Thank you very much. The testing challenge, we started it last year because beta release is out more or less in September every year. And we want to encourage people to contribute to testing the new version of Postgres in any way they can. Go through the documentation, see whether you can find improvements on the documentation, test new features, test the things you think are important. So we really want to encourage you to install the new version of Postgres, download the version, run it yourself, see what's important, and find the bugs as quickly as you can. Because the quicker we find problems, the better the final release will be. So even if you didn't contribute this year, please take how it works this year, download release 18, you can still contribute to the tests, you can still send them in, we will add you to the wall of testers on our website. And then next year, you know how it works. So you take your documentation from last year, like I should have done instead of reinventing the wheel this year again. But I'm a slow learner, what can I say? And yeah, please contribute also to the testing next year. And I think we have way more prizes, Boris. It's a Google Drive, right? It's this thing to collaborate. I'm sorry. Now I feel bad. I didn't say this. Roll back on this comment. But we have more prizes than this one. And you created something cool, right? In Postgres 18, a raffle. Okay, cool. Show us the magic. I think in total we have 5 prizes.
And 5 testers.
5 prizes, 5 testers. Boris told me I was actually, how many seconds late?
No, you were just.
I was just in time. All right.
Yes. So, I would like to thank. I need to type.
Yeah, but otherwise my arm gets tired.
Yes. Okay. So we have a function, a raffle where I can get the prize that I want. Unfortunately, this one was banned by Teresa, so I cannot use it. Luckily, we have the code there, so you can see it. Let me put the Control L. So with a CTE, we just order by random on the list of tester. We create an ID coming out from the row that is created, and we do a join with the prices, and then we will see who gets what. The good thing is that we have the same amount of prices at the same amount of tester. Hopefully next year we have more testers, because it's super important to have testing. And more prices, that will be easier. So everybody's a winner, and Postgres wins as well, because we have tested some stuff. So there we go. So Dirk and Boris get a Postgres mistakes book by Jimmy. These are signed. If you want to see Jimmy, you can get a personalized signature. Guy, where is Guy? Guy is there. He got the Electric Elephant Special Edition. If you want to trade, talk to me later. Dirk, you got a handmade elephant. There you go. So, okay. So, Guy, you want to come? You received the prize. It's a special edition. It's a special edition.
Yeah, I can only do one thing at a time, Boris. Sorry.
It is a special edition where you get really like saying like PostgreSQL tester, and then you can thank Chris for donating this.
Is my name generated by auto-tuning?
I don't know. Okay, so. And then the elephant is for you, Dirk. You can collect it then at the check-in. And Triveni, I don't know. I think Julien this is your team. What? Oh, the elephant is here. Oh, yeah, we can show it. So here are the books and the elephant.
Right. Dirk, are you here?
Here's the homemade elephant for Dirk.
Thank you.
Dirk, you can get the copy of the book.
Oh, wait. I can do this. Boris.
Okay, thank you.
Well done. And
the good thing is that the ebook is a virtual prize, and they send an email so we know how to contact the winner of this book. So it's all solved. Thank you very much. You can continue with the other slides.
Thank you very much. And I want to say a big thank you for all the individuals who donated a prize. So thank you, Karen, Chris, Jimmy, and Ellie. Ellie. Okay, I struggle with names. But yeah, thank you very much. Much appreciated. Last year, I hope to have way more testers than prizes. And then the one you all have been waiting for. I'm so confused. I will not comment on this. Right. One of the other things you always hear at every conference, but only when you organizing a conference yourself, you realize how true it is. Organizing days like this is expensive, and without the sponsors, it's absolutely not possible or extremely expensive. So I want to thank again our 8 partner sponsors for helping us out today. I really hope you visited all the booths and had great conversations with them. And I want to have a really big round of applause for all of our sponsors. Thank you. And then, of course, we also had 4 supporter level sponsors. And again, it's not possible without the sponsors, so please also a round of applause. And then the sponsor passports. Again, yeah, I noticed the box. Thank you very much. Sorry? Yeah, you can still add if you're quickly.
We still have some passports. Please come here.
1 more, 2 more.
Last opportunity. So,
If your passport has 8 times the same stamp, it's not a valid passport.
so I got this
question in the morning, if the first one that you would put on the bottom, that will never be the winner. But let's.
Maybe we should open the bottom. Yeah, I think you did an amazing job. I will also do some.
So there.
So more shaking. What are we doing first? We have a bike keychain, if I remember.
Okay, let's Boris. So our first prize.
First prize. The tulip-shaped reading light goes to Kim.
Kim?
Yes, Kim. Now, we're not doing double prizes. We are only doing one prize a person. All right, what is the next one? Boris. The bike keychain, who can live without it, goes to Bart Smith if you have 8 stamps. Yes, you do. And then 1 package of stroopwafels. Oh, 1 bag of shopping bag of stroopwafels. It's a lifetime supply if you eat slowly. I would just be sick for 1 day. Samuel Lim. All right, enjoy. I think that's all we have for this one. Yeah, I think that's it. I'm sorry for the rest.
Thank you, everyone.
Thank you very much. Thank you for visiting all of our sponsors. And okay. Wait. I'm at the end. I was just going for the starting slides. We started at the beginning and not at the end. That's why I'm so confused. Look, these are the prizes we just handed out. You start here.
Why were you surprised?
Yeah, now I know why I'm so surprised. I was starting halfway through. Now I can check whether we handed out all the prizes. Look, there they are. All 3 of them we managed. All 5 of them we managed. The live stream. So again, we want to offer the possibility for everyone who was not able to join in person for whatever reason to join the live stream. We had a stable amount of viewers throughout the entire day and a few new subscriptions. So if you want to see the talks coming online, either you are a participant or you want to see your own presentations back as a speaker, we will post all the presentations in the same feed. So please subscribe to the channel and then you get notified when the presentations are coming online. And then we go forward again. And I think we can already say next year, again, it will be in the Lowlands and this year in Utrecht. I think we can only say what venue it is if we have a signed contract with them, which I think we only have an option. I don't want to... We have plenty options. Utrecht is a huge city with lots of places where we can organize this. If you're not growing to 1,000 attendees next year, I think we're safe. So yeah, next year, we will hope to see you all again, but this time in Utrecht. And this is where you can find this. You can send us emails, contact us on LinkedIn, Mastodon, Bluesky, and I don't know where my slide about feedback is. Maybe it's the next one. No, it's not the next one. So there is some slide in the deck about feedback. Feedback is important. Sometimes people blame me for giving feedback very bluntly as a Dutch guy. I was giving Floor feedback last week. I don't know exactly what she said about it, but it was Dutch apparently. But yeah, feedback is important. It's important for us as event organizers. It's important for speakers. It helps us to identify in how we can grow, what we can do better. What should we do again next year, and what should we no longer do next year? So please give your feedback and don't say it was good, because then I don't know what you mean. Can you please add a little bit of text, whether it's about the venue, the speaker, the talk, give some feedback. It was good because of, I remember, I didn't like the coffee because of whatever reason, right? Don't say it was good or it was bad, because then we can't do anything with it. Please be specific. It's the only way for us to do it better next year, and we want to do it better next year. And then I think that's where I end it. Am I forgetting things? Did I have more slides I forgot about? Yeah, I did. I did say the recording thing. Yeah. Right, and then, yeah. All right, we can go out, we can have a drink, talk more about final topics we want to talk about technical things, talk about beers. What's your favorite beer, your favorite wine? How do I know where the karaoke is? If you want to do karaoke, you go to floor. If you don't want to have anything to do with karaoke, you can come with me. All right, thank you very much.
PGDay here, Rotterdam, yeah. 20 to 5, Lowland is live. PGDay here, Rotterdam, yeah. 20 to 5, Lowland is live. PGDay here, PGDay here, PGDay here, PGDay, PGDay, PGDay here, Rotterdam, yeah. 20 to 5, Lowland is live.
Welcome to PGDay Lowlands, Rotterdam 2025.
PGDay here, Rotterdam, yeah. 20 to 5, Lowland is live. PGDay here, Rotterdam, yeah. 20 to 5, Lowland is live. PGDay here, PGDay here, PGDay here, PGDay, PGDay, PGDay here, Rotterdam, yeah. 20 to 5, Lowland is live.
Welcome to PGDay Lowlands, Rotterdam 2025.
PGDay here, Rotterdam, yeah. 20 to 5, Lowland is live. PGDay here, Rotterdam, yeah. 20 to 5, Lowland is live. PGDay here, PGDay here, PGDay here, PGDay, PGDay, PGDay here, Rotterdam, yeah, 20 to 5, Lowlanders Live.
Welcome to PGDay Lowlands, Rotterdam 2025.
PGDay here, Rotterdam, yeah, 20 to 5, Lowlanders Live. PGDay here, Rotterdam, yeah, 20 to 5, Lowlanders Live. PGDay here, PGDay here, PGDay here, PGDay, PGDay, PGDay here, Rotterdam, yeah, 20 to 5, Lowlanders Live.
Welcome to PGDay Lowlands, Rotterdam 2025.